На своих плечах несет это бремя, поддерживает сеть. Елена Якупова, рад тебя приветствовать сегодня.
Спасибо. В 2021 году мы наконец вернулись в офлайн, при этом сохранив всю гибкость, которая в нас выработала наш удаленный год работы. Поэтому сегодня мы собрались здесь в привычном уже для всех гибридном формате. Часть зрителей у нас находится в зале, и мы их видим. Часть зрителей, большая часть у нас находится в онлайн. Мы их не видим, но мы знаем, что вы с нами. Ребята, не отключайтесь, смотрите, будет интересно.
Да, у нас доступны две трансляции, русскоязычные и англоязычные. Ссылочки есть в программе, выбирайте ту, которая вам больше нравится. Здесь в зале мы выводим оригинальный звук, но если вам вдруг нужен перевод, то это тоже можно организовать. Можно взять, собственно, суфлер. Вот. Немножечко вводной части. Как Лена заметила, сегодня мы собираемся уже 4-й раз. Мы потихонечку растем, мы уже не такие маленькие, матереем, так сказать. И начиналась эта конференция как желание рассказать вам о том, как мы строим сеть Яндекса внутри. С желанием поделиться самым сокровенным, желанием рассказать, какие у нас есть проблемы, какие у нас есть подходы, как мы их решили. И мечтой о том, что вы придете сюда к нам и расскажете примерно то же самое, что вместе с вами мы сделаем комьюнити, что мы сплотимся вместе, будем что-то обсуждать, потому что разговаривать о сетях – это самый лучший способ получить новые знания. Мы здесь ради вас. Если вы уйдете отсюда с какими-то новыми знаниями о технологиях, возможно, каких-то решениях, мы будем считать, что мы действительно выполнили свою миссию. Немножко про правила поведения. Вопросы насчет их доклада, не знаю, возможно, что-то на отвлеченные темы. Мы приветствуем любое общение. Как мы говорили уже, программа доступна на нашем сайте. Здесь она продублирована. Читать я, конечно же, не буду. Я думаю, вы сами справитесь. Все вопросы, пожалуйста, в наш чат в Телеграме по хэштегу question. Внимание, мы будем разыгрывать футболки среди тех, кто задаст самый интересный вопрос.
Yeah, so the 6th of October 2021, Yandex Moscow and nexthop of 2021 is officially starting. So our conference, first speaker will be the leading network expert of Yandex.Cloud, very experienced guy and technical lead of automation group, and my good friend Marat Sibgatulin. And I think how many network engineers in mail.ru group used Marat's articles when they were training for their profession? Well, we don't ask them during the job interviews. But, whenever people approach me and ask, what kind of book can I read to learn everything about networks? And I refer them to Marat's articles. Well, I want to talk about a skeleton that I have. I grew on Marat's articles. Yeah. Hi. And except for starting the conference with my presentation, I feel really, really responsible now that I feel this load of responsibility after what guys said. So the cloud has been in production for 3 years, and I'll tell you about how we were creating this cloud, how we are developing it. And a logical question comes, so what are you going to talk about? Because basically it's clear how such networks are designed. We have cloths, we know how to scale it, what kind of routing protocols we have to go for, because Facebook and other guys have published so that how to create links, it's clear. So why are you here? Well, let's start step by step. I'll talk about what kind of tasks network architecture has when it comes to public clouds. And I want to say that the network lifecycle in terms of software and hardware and maintenance is covered by us. It's an end-to-end process. We cannot rely on vendor solutions. We do not hire integrators for create networks and service networks. So we don't outsource, and our services are provided solely by us. So what does the team do? Well, first of all, it's a switch fabric for the service to be able to interact with each other, and then the edge of data center for us to be able to go outside this data center and connect to different environments. And we service DCI and the backbone, and naturally, it's external infrastructure, it's borders, reflectors, peerings, and so on. And one of the most popular services is Cloud Interconnect for direct connection of clients to the cloud. So this is the whole technology stack to protect from DOS attacks and from fraud. Naturally, we cannot develop the network and we cannot service it without monitoring. Qualitative, quantitative, white box, black box notification system. And last but not least is automation and internal tools. Basically, when I was preparing this presentation, it was supposed to consist out of 3 parts. Physical network development, then automation that allows us to speed this process up, and monitoring. Unfortunately, we cannot delve deep into each of the sections or segments. That's why I'll be focusing on physical architecture. As for the rest, I'll be briefly mentioning the rest, and I'll be happy to reply to your questions. So, 4 years ago, the cloud was launched. And what kind of an initial situation did we have? Well, I must say that cloud is a very important part of Yandex, and that's why we are trying to use all the 20-year-long experience of Yandex of using our own infrastructure. We are using the same data centers. We are using the same service racks that were developed by our R&D department. We use the same servers. So we are trying to make the operation as seamless as possible, reducing the workload for people. As for the network, what kind of networks do we take from Yandex? IPv6. But as for SDN, we went for Open Contrail that requires default IPv, so we have to support dual stack. Unfortunately, the market supports that and offers the solutions. And a number of routing entities like Cloud Gateway, network load balancers, and some other entities, they are launched within the cloud perimeter. They're the same VMs, the regular VMs. Well, a little bit special, but basically it's a usual virtual machines, and we do that to make sure that we can scale up horizontally without waiting for the orders for cooling rooms and so on, waiting for months. So we're just launching the new entities, and we are expanding, and it takes minutes basically. So for such entities to be connected, for instance, with borders, we need a tunneling protocol that help to hide the load from the network, from the fabric, from the backbone. And we went for the solution that you can see on the screen. We have some differences from Yandex. We have specific policies for routing and so on. And I think it's no secret for those who are here that Yandex runs regular drills, and once every month a victim data center is picked and the drill is happening. And initially the Yandex services are designed at the level of -1 server. And the same is true for Yandex Cloud, but we cannot expect the same thing from the clients, because they might have the single virtual machine, and there might be losses if something goes wrong. Of course, we explain what kind of high availability, what the cloud is.
So on the other hand, we can't demand it from the client. So and such kind of training can turn out for us into some kind of the reputational risks, or even direct loss. So that's why we can't do this training like it's happening now in Yandex, unfortunately. And one more important thing, so more or less the existing tools, Yandex network exploitation system, or monitoring exploitation system, internal tools, inventory system, they all are made according to the Yandex tasks, and all those conditions, they have led us to the only one idea, that we have to build our own network. And when we accepted this idea, we have decided the following principles of our development. They are probably very obvious, but I would like to speak them out. First of all, we are projecting and design our network with a long time ahead, for 10 years ahead. So this design for cloud will long us more than 10 years ahead. So for this reason, we have chosen close IP environment to send, and all those things which we don't need to redesign in the future in order to build the new services and them on new needs to the services of our cloud and to our networking. So we plan for the years ahead, and we have understanding so how networks will be in the future. Even if they are very unexpected, we learn ourselves, we train ourselves to be ready for this. So, for example, in next 6 months, if we see that we need 10 new stacks, they're ready to build them. And we're ready to build in that way that we don't need to spend all our budget and all our free time. And two more conditions which we have created from the beginning and trying to follow them. So if something is restricted, if something restricts our development, then we need forget this. We have created something for ourselves to create it by our own means and our own solution. So, and the next automation for us started from the first days of our cloud, and it helps us to decrease the operational burden. So, for example, we have 100 stacks at once, and if we take a person who will do it manually, it's so big burden on one person or on personnel, and also it will lead to the configuration errors. So routine actions, regular routine actions, person will fail. Robots can do this, human not. Also, automation helps to vote briefing, so which again human can do it manually, and also it moves us on a way zero-touch prod. So I would like to tell that we are somewhere in the middle of this way, but on another hand, we are somewhere far from manual work, manual installation. And I would like to tell one story what we've got, which helps us to get success, and I would like to boast about this success of our cloud. So 3AS, 5 points of presence, were our borders of interconnection. Borders, 1,000 servers, thousands of stacks, 800 gigabits uplinks from every stack. Everything is built on 5-stage close or 2-level folded close. So it can digest about tens of terabits inside of data center, 1 terabyte per second externally from data center, from every data center, and plus. So that we already started to say that our cloud started international expansion. We go to the other countries and regions. These are private clouds and G-Cloud. So that what is Yandex.Cloud today. How it started? 2016. And it was idea to organize public cloud on resources of that Yandex resources. And the idea started to raise, started to begin to grow. It was very bright, it was very brave engineers and developers. They started to develop the idea, to support this idea in terms of virtualization of network. And then it was experimental project Yandex.Cloud 2017, 2 stacks, and network infrastructure department, which we call Net Infra Inside. So initially it was consisted of 1 person, then it was 2 person in this team, Net Infra. So the solutions was tested OpenStack, OpenSwitch, OVN, so solutions on computer virtualization, and etc. What about Department of Network? So we have 2 stacks, and so why we needed networking engineers? But they did the fundamental development, the foundation where the cloud starts, would start in the future. And at that side, these are our walls. Our walls was just had different plates, and not only cloud in all Yandex. If you follow a corridor in a Yandex, you will pay attention that we have wall depicted, wall painted, all ratings. This is the creative work. So, and we built the connections, automation, prototypes, testing, creative work on the walls. And the results of all these trials and attempts so became our product, which we launched on infrastructure. So, and we have several hundreds of servers, and infrastructure, of course, was ready already of external connections, borders, reflectors, and we had stacks. We used fabrics, not Yandex. We used backbones, DCI, and etc. And that time already the beginning automation started. But I mean automation not like idea or couple of scripts. I mean, so the prototype of the system, which had a big burden, decreased from the operational engineers. So this how our network looked like. So stacks was connected in spines, spines connected in VG, in backbone, and organized connections between data center. It's maximum. Simple, had restrictions, but it helped to launch the production for us, beta clients, first clients, and then we had constant clients. So automation, I would like to tell something about automation. So at that time we already had IPAM system, IP, ISM, and we organized switches launching into the system. So IP allocation, virtual interfaces, all those were automated on the samples, on the targeted configuration, which we did manually before networking. And of course, there were so much compromises, so much agreements, so much static sections, configurations, samples, point-to-point links towards the spines, policies, targeted, and etc. But on the other hand, it helped us to launch into production stacks delivery. And when we begin in developing network, we created very simple rules. Configuration on the network should be very statical. From the switch to switch, and configuration should be changed minimally. IP, VSN, so which is individual for the every hardware. The other thing should be statically, and the same dynamic in time. Configuration from day to day, from year to year, it should be changed minimally. Minimum. So we had dynamic parts, they are automated also, and I can tell about them also, but in general, this statistics, more or less statistic story, static. So, and also we had automated external part because we had vendor who supported normal webcon state configuration, and we just only crafted XML conflict. We send it to hardware. It's right delta and supported configuration in the form which we needed, and it works up to now without any fails. Everything is great. So and then we reload. We take new stacks. We have automation. We have monitoring. Everything is good, and then what just had to be just to add new stacks and continue to grow. No, but it was not that simple like that. We understood that first year, it's like smoothing configuration, smoothing design. So because changes are happening very fast, and they can be big, and when the new stacks arrive, we need to connect spines. Spines should be adjusted, automation here, automation there, and it's different zones of responsibilities. And we realize it should be a person needed to control. It's not a big deal, it was not a problem, but the challenge was IPO. For IPO, IMPLS. For the clouds, it's natural things. They are integral part of networking structure, and Yandex tried to avoid them to simplify network, because to support these protocols can complicate situation. And so MPLS restricts the equipment and chips on which this equipment can build on. So MPLS has many restrictions. And work and training Yandex. So one cloud in a zone of risks in terms of isolation of data clouds. So all those conditions come up into the idea that we have to build our own networking. So, and demands for this networking, horizontal scaling, MMLSP, single chip pizza box, 326400 gigabytes interface, and market then time offered assortment which is in compliance with these conditions. So we have selected Tamagov 2, FG, Rabin 3 in the solution. So by that time we regretted about those solutions, but this is different story for different presentation. So for the stage number 4, so immigration of the initial segment into the new scheme. So we already have 5 persons in our team, NetInfra, Sway DCI. We have our own DCI. We have DCH, NOC, and we have already anti-DDoS and cloud interconnect service. This network looks like this. So the same stakes we used before, they're already included in our cloud spine. Then you can see edged spine bone button, which organized those connections. To realize that project, we had to have additional stakes in data center spines and patch panel, consoles, and etc. This you can see on the right picture. On the left picture, you can see typical stage of Yandex of service of the previous generation, which is in the middle, the pro switch. And the second stage also has its limit in terms of growth, and we were ready for the 6,000 servers. 6,000 hosts might look for some clouds like probably something unachievable. But for us, it was not a limit. We didn't set this limit for ourselves. And even we did, for us, it was fatal for now. And that's why all 2020, we had new layers, Marcus, on the whiteboard with new schemes, we extend those. So we satisfied new demands of services, we created laboratory environment, we tested different scenarios, we made experiments for the Vulturi enterprise dual homing servers. We had apparatus standards, we did testing, apparatus fails or peculiarities, and performance testing, of course. And the result of all that things in 2020, so we had multi-level clause, 5-stage clause, and it's time for pod. Point of delivery. This is universal constructual unit, which is about 32 server stacks connected into 8 spines. And when we need to extend this network, we have some kind of hardware which is stuck into 2 spines of second level, and it's ready. And we have like second level spines of our own. If it's spine first, this is a thing which helps us to connection between servers in one pod, but spine 2 helps to connect between pods. And in the same 2020, we had request for the private cloud. This is some kind of nanofabric for certain amount of servers with the same servicing of public cloud, and which we can send to the flow of customer and launch without connection with the mother cloud, and it will work. So for that time, we need to train to work, to learn to work, and support and maintain this beautiful ready 5-stage, and also to build this independent clauses. So the network that time looked like you see this in the picture. The same stacks, spine 1, pod 1, and those spots included in pod 2, and edge is connected in pod 1, ordinary pod 1. 2020, you can see our network, 4 plane, 2 spines 2, which organize 400 gigabits per second, and 2 spines in every plane, for those who are familiar with this network hyperscaler, so probably it looks funny, it looks ridiculous. Even Yandex, when has tens of spine too, we have 2. So because we didn't have demand to do more, when we decided to simplify, we decided not to install hardware which will heat the air. That's why we have selected 2 things, and between spine 1 and spine 2. So, and we have organized LAC. Why exactly LAC? I will tell it in the break because I don't have time now. So it helped us to have 6.4 terabytes per second at the level of spine 1, spine 2, and it's already mentioned in pod 1. So as far as for the growth, we have this beautiful wide network for thousands of servers, and FineStation helped us tens of thousands connect of services. And for the further expansion, and we understand we are big, and we understand that in company there is a situation that we have 2 big networks with 2 different designs, different demands for cascades. We have 2 different departments for development and automation, 2 different monitorings, and it seems like we do the same work twice. And the next 2021, so it's a gate of Yandex Cloud, and we do the same modification. Now we already have 9 person in our department, and all these people, all our team, have tasked to develop our service, extending to other countries, and also make modification, unify the single design in order to use this network infrastructure and data center. So all those things, when the cloud goes together with Yandex or commutators or models, totally can be switched on CloudWorks or on YandexWork, and this experience of engineers exploitation seems seamless. This minimum time of requirement. And when we send this model from the Yandex, we don't need to change escalation or adaptation in this thing. And this course of modification, so it's going on everywhere, not only in module or routers. So, and also we have course to extend, to expansion. It's our own backbone. So it's 800 gigabyte from stacks, and increase numbers of spine 2, and it's already mentioned this year, G-Cloud and geographical expansion. So, and totally 2021, we can see our network, 8 planes, so 4 spines 2 in every plane, between every pair spine 1, spine 2 legs in 4 links. What helps us to has.
And that allowed us to get this kind of terabits. So, drawing a brief line, what the costs were and how we were saving by these iterations. At the first stage, we needed only servers and TORs, actually cables and transceivers. At the second stage, we placed 19-inch racks, 2 per data center, then 4 spines per data center, edges, cables, and transceivers. Third stage, we have expanded extra racks, first spines, first spine, second spines, and stage 4, when we were growing this beautiful big network, we got additional 4 spines for every pod, 24 second spines, because we had more planes and we had more spines within the plane. Edge spines, 8 per data center, and our routers, 4 pieces to have our own backbone. Unfortunately, I didn't have time to talk about automation and monitoring because this kind of fast growth. I didn't know whether I managed to communicate how fast the growth was. Without that, it wouldn't have been possible without it. So next year, we'll try to talk about automation tools, about our internal PI tools that we are providing to other services, and we'll talk about the internal infrastructure that we need to maintain those network tools. Thank you very much, and I'm happy to reply to your questions, probably not now. Yeah, good timing, and we have 5 minutes for questions. And first question is mine. Do you place your services within your commercial cloud, or is purely commercial cloud, or have you considered that? Well, I cannot tell you whether it was we were thinking, but we were using our sites only. Yeah. Do we have questions from the audience? Yeah, while we are getting there, I'll ask you a most popular question. Why not VXLAN? Why you went for us? Because the boxes are more expensive. It's a very painful question. We have a presentation from our previous manager why this was the option chosen. I don't think it'll be possible to reply to this question briefly. But MPLS fits the requirements, and we are not using overlays on network entities. Initially, when we were starting, it wasn't that easy, and MPLS was one of the ways out. What about the future? I don't know. Maybe in future we'll stop using them. We'll see. The question. Hi, my name is Igor. I would like to ask about the new anti-DOS attack services. You haven't given us the details, and you have certain equipment set. So, do you use telemetry? I'm not asking about the system. Maybe it's restricted access information. So, did you have to change anything about your set of boxes? Well, on the one hand side, anti-DOS is a complex solution that requires some computing too. And in terms of network infrastructure, it's us working with external party. As for compute, it's very interesting that we have to we have to do some extra work in virtual machines that help us minimizing the aftermath of DOS attack. Okay, we have 1 more minute for another question. Good morning, my name is Stas. My question is about lags on leaves. Do you use 2 switches for redundancy or 1? We have only 1 leaf, and we were considering dual homing, but we haven't considered lag, MC lag, or any other solutions because almost all of them are proprietary, and we are not ready to risk it. And our scheme was about taking BGP from the host itself with 2 leaves and announcing routes both there and there, but switching. And we didn't do that because it wasn't economically feasible, and it's easier to remove the extra load from the rack and working on leaf. Quick teaser, we'll have a presentation from Sasha Petrovsky about that. Yeah, if it burned down, then you have to redistribute between VMs. What about data? You have to replicate it. Have any other questions? Just 1 minute. Wow, did a good job. You did everything on time. Thank you very much for your presentation. But could you said that you don't want vendor lock, but unfortunately, you said that everything's well, but unfortunately, vendors say often say that, oh, unfortunately, we don't produce it anymore, or it's under sanctions and so on. So, how do you mitigate those risks? Because you need to grow all the time, and neither you nor us have guarantees that the equipment will be available tomorrow that you are already using. Well, unless we take into account MPLS, and we indeed have a lot of problems when we are scaling up. In other cases, we use the most standardized and universal protocols. That's why we are not using MCLAG, and if one vendor stops manufacturing the equipment that we have tested, we switch to a different one that supports stack protocols. And we need to be ready for that. That's why we have multiple vendors on the same plane, and we're always testing new equipment against the requirements that we have. So one vendor failing won't cause problems. Thank you very much, Marat. I think with that we conclude. We are out of time. Please chase Marat in the hall outside and ask him your questions there. Just a second.
Так, сори, одну секундочку, у нас
Sorry, just 1 second. We have technical glitches. Just a second. So our next presenter is known for his involvement in Knock, the Roundtable Table podcast, Melchior Aelmans from Juniper Networks. And he'll be talking about quite an unusual subject when we talk about networks. And it makes it even more interesting. It'll be in English, and if you need the Russian language, you use the device.
Can you hear me?
Yes, I can hear you. Good morning.
How are you?
I'm doing well. Thanks for having me today.
Okay, so the floor is all yours. Let's start.
All right, thank you very much. So, good morning. My name is Melchior Aelmans. I'm with Juniper. I'm based in the Netherlands, and I'm part of a study group that is looking into how can we leverage quantum technology in current networking protocols and infrastructures as we know them. So, I thought I'd give an update on what we currently can do already with quantum in general, so not per se Juniper specific, and we'll look at the applicability and how far this technology is. So before we get started, I want to give a quick update or introduction to some of the language and terminology that's used in quantum. So we have more or less the same baseline. Then we'll look at what is actually quantum networking and a quantum internet, if there is a quantum internet. And after that, we'll look into quantum key distribution, which is a technology that is currently available and could be useful in current security protocols as we know them. So what is it and what isn't it? QKD is a method to use quantum technology to distribute quantum states. So we're not generating keys magically with quantum. We are distributing keys using photons in this case. We do not use any quantum computers. So in order to use this, you do not need any really large cooling systems that you would need for a quantum computer. And also, it's not about quantums protecting the network. It is enhancing current security protocols to protect them against attacks from quantum computers that might happen in the future. So it's maybe not that spooky as it sounds. So what is the problem statement we're trying to solve today? Our current security mechanisms we're using to encrypt data, like, for example, MACsec and IPsec, are in basic very secure and robust, right? If at one point in AES someone would be able to factor the key, then we'll just use a larger key, simply said. The issue is, how do you communicate the key between the two sides that would want to encrypt their communications? So the way to synchronize and distribute the keys, that is the weak link in the whole security story currently. And that is because at one point it is expected that a quantum computer becomes so powerful that it can easily factor prime numbers. As you probably recall, a majority of security mechanisms are based on prime numbers. So if you multiply two prime numbers, that's really easy. The problem is try to factor a prime number. With small prime numbers, you and I can do that, but with the large prime numbers we're currently using, it is almost impossible, or at least it would take a very long time for a classical computer to factor those prime numbers. Shor's algorithm is an algorithm that runs on a quantum computer, and that makes this factoring job much easier. And so it's a threat for public key distribution. So let's see what this quantum thing is. Probably the biggest difference is that in classical computing, as the physicists refer to what we're doing classical networking, we use bits, and a classical bit is either 0 or 1. In quantum, a bit can be 0, 1, and basically anything in between and at the same time. That is what they call a superposition. I have to note, I'm not a physicist, and this is not a physics class, so we'll only scratch on the surface a little bit of how this works. But one of the really interesting properties of a qubit is that you cannot copy it. Qubit is basically a photon that is being brought into, as I mentioned, a superposition. We'll get to how that is done. And if you try to copy it, then the superposition collapses. So in other words, that is an advantage for security because no one can copy the qubit. The downside, obviously, is that in a fiber optics network, you cannot use DWDM and CWDM because that would also destroy the superposition. Now, what is a superposition? A superposition is basically describing the state the photon is in. Right, as I mentioned, in classical computing, a bit is either 0 or 1, and in a superposition, it can be 0 and 1 at the same time. The way to do that, in really short, again, this is not a physics class, is you take a photon and you use a laser to give the photon a certain spin. And the spin could be 0 degrees, 45 degrees, 90 degrees, or 135 degrees in the application we're using it for in quantum key distribution. Now, if you would measure that photon or observe it, then only you will know what the position of the photon or the superposition was. But as I mentioned, by observing it, you will also destroy the superposition. If you're interested in more, most of these slides have a link that leads to a website that gives you further information. One other interesting aspect, and what you might have heard from science fiction movies, is teleportation. In this case, we are not transferring physical objects, so we cannot teleport ourselves, but we can teleport quantum information. As I mentioned, these photons we bring into a superposition. You can send them over a regular telecom fiber, or using satellites, you could transport them over free space. And the interesting thing is, if you now entangle two of these photons, in other words, you bring them so close together that they sort of start behaving in the same way. In other words, their spin becomes the same, and you take them apart. If you observe a photon on one side and it collapses into 0 or 1, the photon on the other side will give you the same outcome, and that is a quantum property that is unique for this, and that is something we can obviously use to transport data. So what are some of the advantages? As I mentioned, no cloning, right? You cannot copy a qubit, so that makes it ideal for security. Also, the superposition collapses when you observe it. So if an eavesdropper would try to interfere in the quantum communication and observe the photons, as I mentioned, if you entangle two photons and someone tries to observe one of the photons, the other one collapses as well. So you know that someone is observing the communication. And the third biggest advantage is that it is using physics over math. As I mentioned, at one point, a quantum computer will become so powerful that you can factor the prime numbers we're using. Obviously, you cannot factor physics. So that is one of the biggest advantages. Obviously, there are some challenges as well. Decoherence. At one point, a photon in superposition or qubit will always collapse. So one of the biggest challenges for the physicists currently is to maintain that superposition for longer periods of time, because the longer you could store the data, for example. Also, these superpositions are really sensitive for interference, like, as I mentioned, in DWDM, CWDM, you cannot use amplifiers. You need to have a good quality of fiber, etc. Another thing is the fidelity. Fidelity describes, in really short terms, the quality of the qubit. So if you entangle them, in theory, you should always get a 0. If you observe one photon, it should collapse to 0, and the other one should collapse to 0 as well, and same goes for 1. However, in practice, it doesn't always work. So the quality is just good enough to make it somewhat applicable. And scaling is obviously an issue, and we'll get to why scaling is an issue. So how do we use this in a network or in a quantum internet? Basically, there is no quantum internet yet. Where we currently are is at its best to be described as a peer-to-peer connection, where there's two parties, Alice and Bob, and Alice can send photons to Bob. Bob can observe the state and observe the quantum state of the photon. So that is at its best. Obviously, the idea here is that at one point we'll be able to use repeaters, to use routers to route those quantum states. And going back to scaling, one of the biggest issues as well is, as I mentioned, you cannot use amplifiers. So the current maximum distance is around 120, 140 kilometers in telecom fiber. So that is a big issue that the physicists are looking into, trying to build quantum repeaters, for example, in order to overcome that maximum distance. So what are the physicists currently working on? We're basically trying to translate that peer-to-peer network and extend that with a sort of overlay model as we know it in MPLS, for example, where, as you can see in the middle of the slide, there are still Alice and Bob who exchange qubits, and Bob and Charlie do the same. Both entangle photons, and Bob will do what's called entanglement swap action. So A and C will both have photons that are entangled with each other. That is basically how they're trying to overcome that 120 kilometer distance. As you might notice, this is all still basically point-to-point or one-to-one relationship. So another thing which needs to be solved is, are we able to entangle more than two photons? In electrons, this is already possible in the lab. So recently, physicists were able to entangle 3 electrons, but with photons, as far as I currently know, that is not possible yet. So if we try to project that onto a internet, what we'll probably see happening is, at least in the near future, is that you will have a end node, which is in this case projected as a computer, that will have a classical connection, so just IP, and a quantum connection. In networks that use CWDM without amplification, you can do this already over the same fiber, just using different wavelengths. But the distance in practice is then reduced to only 20 or 30 kilometers. So it's even worse than the 120 if you would use it without CWDM. But this is how currently it's foreseen a quantum internet would look like. So what are some of the applications? Obviously, applications that would need perfectly synchronized data on both sides. So for example, clock synchronization or baselining of telescopes. Obviously, as well, sharing memory and communication between quantum computers. Much of that is still only possible in perfect conditions in the labs. But what is currently available is what I already mentioned, quantum key distribution. So let's look at how that works. So as I mentioned, the issue with public key cryptography, basically Alice and Bob are sending data in between them, and they do not want Eve to eavesdrop on that. The way they send the data, for example, encrypt using MACsec or any other protocol that's based on AES, is perfectly secure and will still be very hard for a quantum computer to intercept. However, the way they exchange keys is the biggest issue. So ideally, you would want to use symmetric key cryptography, where Alice and Bob both know the key, but do not have to share it. The problem, obviously, is at one point you will always need to share the key, because Bob will never be able to decrypt the message if it doesn't know the key. So you could do it by snail mail or Diffie-Hellman or other key distribution protocols. However, as we already discussed, those are vulnerable for a quantum computer. So again, why is quantum superior over math? Math is always vulnerable to factoring, right? Whether it's a classical computer that becomes powerful enough or a quantum computer having a mechanism to factor those keys. So RSA, Diffie-Hellman are very vulnerable to quantum computers. On the other hand, the way we encrypt the data in symmetric cryptography using AES is secure. And as I mentioned, if at one point the quantum computer would be able to factor the key, we'll just double the key length and we're safe for a couple of more years. So now, what if we would use quantum to distribute the key and use AES to encrypt the data? That would, in theory, lead to much more secure communications. So a protocol that can be used to distribute those keys is BB84. It's invented by Bennett and Bressert in 1984. And it basically describes a mechanism, as I mentioned, using photons that are being brought into a superposition by Alice. Bob has a so-called photon detector and can observe the superposition state of the photon. So let's see how that works. Alice sends polarized photons, as I mentioned, in either 0, 45, 135, or 90 degrees polarization to Bob. Bob has a photon detector that can read the state of the photon, and as you can see, it observes the states in almost 100% of the cases. Now, both will do a measurement on that photon, and this is why this is resilient to eavesdroppers, because both Alice and Bob will measure the photon using a filter. And as you can see, the filter either allows 0 or 90-degree polarization, so the cross-shaped filter, the plus-shaped filter, or 45 or 135 degrees polarization, the cross-shaped filter. Bob obviously doesn't know before it applies the filter what polarization Alice used to send the photon. So in other words, as you can see in the example, it sometimes tries to filter a 135-degree polarized photon with a 0 or 90-degree filter. So there is a certain error rate. And now the interesting thing is, if an eavesdropper would try to intercept and observe these superpositions as well, it doesn't know which filter to use. So after applying those filters to the photons, you'll see we get a certain measurement. And in some cases, the measurement is wrong. And now both Alice and Bob will exchange their filters. And as you can see, if the filter matches on both sides and matches the correct polarization of the photon, you'll get a result. Now, if Eve will try to intercept, she obviously doesn't know which filters Alice and Bob have used, because the way they exchange the filters is via a separate channel than the quantum channel. So Alice and Bob's QKD devices will have a quantum channel in between and a data channel in between themselves. So they exchange the filter, they sift through the results, and obviously you will then get some of these photons will match and some not. And because after sifting through the results, you will get a key. This is how one of the current most, let's say, popular QKD protocols work. If you're interested, again, there's a link to a YouTube a movie that really explains this in depth. But this is in basic how QKD can distribute those keys using quantum aspects. Now, if we apply that to, for example, back to our routers, we basically replace Diffie-Hellman or any key distribution protocol with what we just saw, this QKD mechanism. And how that works in practice is we have an Alice and Bob, and Eve will try to interfere with their communication. So Alice and Bob both have a QKD device. Alice has a transmitter and Bob has a receiver. And both have a router. And that router is just using standard protocols, MACsec or IPsec or whatever. And the channels in between, as I mentioned, between the QKD devices, there is obviously a quantum channel. Again, it could be telecom, fiber, or free space. And you need a data communication channel in between because they need to synchronize the filters they applied. And between the routers, there's a link, MACsec or IPsec, or what have you. So how it works, Etsy has defined a standard REST API that you can use to ask on Alice QKD device, I need a key. Then a key and a key ID will be sent to the router. Obviously, the key will be used to encrypt messages Alice router is going to send. We send the key ID to Bob as well. That doesn't have to be encrypted because the key ID itself isn't usable to decrypt messages. Bob router will use the key ID to fetch the key from Bob QKD device. Obviously, it gets the key back, and now both are able to use that key. If you want to make this even more secure, obviously, key rollover is also really interesting. So you want to use a protocol that allows for hitless key rollover. And obviously, the faster you roll over the key, the harder it gets to factor the key. And if you factor the key, you probably already have rolled over the key. So this is how you could use what is currently available QKD in current security mechanisms. As I mentioned, keys are exposed using an etc REST API, and that is available. There are some vendors of QKD boxes that also expose a simulator, so you can already start playing around with it. The question is, what protocols would be interesting? Probably it's MACsec, IPsec for security, but also authentication protocols that allow for hitless key rollover, for example, TCP/AO. And as I mentioned, there's QKD products available. I mentioned at the beginning, are also some challenges. So one of the challenges, again, is obviously the distance, right? So how are we going to overcome the 120-kilometer distance? Some of the QKD vendors are trying to overcome this by using satellites, but then obviously every data center would need to have a receiver, and you need satellites, etc. So that's not really interesting for everyone. But there could be interesting to look into using key distribution that is based on post-quantum key distribution protocols, for example, or post-quantum encryption. Same goes for remote or home workers. How are you going to use this for home workers? You have to imagine a QKD box is somewhere in the range of between 50 and 150,000 US dollars. So it's not really something you're going to have at home. Another thing, multi-point. So imagine a service provider or, for example, Yandex offering QKD as a service. How are you going to make that multi-point? So you see there's still quite a lot of challenges. But as I mentioned, there is simulators available that you can currently use to at least get started. We have done some demos. Competitors have done some demos, for example, with MACsec. Those can be showed. And I don't think personally this is the end goal, but it's a nice step into how to leverage quantum aspects in current security protocols. If you're interested, there's quite some material. There's some work in IETF going on, trying to define, for example, principles for quantum internet and use cases. Obviously, physicists and universities have done quite some work, so there's some really interesting material. And if there are any questions, feel free to ask them now or reach out to me by email.
Thank you, Melchior. It should be no question or one question or something in between. We don't know. Correct?
You never know if there's a question or not.
Yeah,
you only know when someone asks the question.
Questions? Yeah, we have one question. Пожалуйста, если вы задаете вопрос, встаньте, представьтесь, вот, иначе вас не очень хорошо видно на трансляции.
Well, hi, I'm Vladimir. Thank you for the talk. This quantum cryptography and security rely on the first connection to be on a guaranteed non-intercepted physical link. As far as I can see, BB84 doesn't provide any source of authentication that Alice is Alice and Bob is Bob. It's just crossing. It's just
Yeah, excellent question. Agree. So the issue is not per se on, I think, the quantum channel itself, because as I mentioned, Alice and Bob will need to be able to communicate on a classical channel and the quantum channel, right? If someone would try to imperson Alice on the quantum channel and the original Alice and Bob are exchanging their filters, they obviously won't match. So the error rate will be very high. And that's a signal that someone is interfering in the connection. There are, however, challenges, for example, with the REST API. Obviously, it's currently expected that LSQKD and LS router and LSBOB and Bob router are in a what's called a secure location, because obviously you can still interfere with the connection between the QKD device and the router. So there's definitely challenges there. You would at one point during initial setup preferably need to know obviously that the connection is secure. But as I mentioned, because it's using two different channels, if someone would try to imperson someone on one of the channels, then the error rate will increase immensely. So that's a sign that there's something wrong. So it's partly covered in the way it works. But I think the biggest challenge currently is with exchanging the keys between the QKD device and the routers or the devices that consume the keys.
So seems there is no questions from my side. Thank you to join us. Thank you.
Thank you very much. Thanks for having me.
Андрей, если я ничего не путаю.
Andrey, so Yandex, you worked in Yandex as a network operator. Yes, I did. Have you ever seen about network operation? So, but I will tell you the policy. If I don't know policy, then it's everything's okay. Okay, the next speaker, this is Evgeny Safronov. He's representative of Yandex. He's head of the networking, and he will tell us how to build network filter on the base of DPDK. So we give a floor to our next speaker. Good afternoon, everyone. My name is Evgeny, and I would like to tell you a story about how we did our firewalling in our new Rails, and we didn't break anything. So let's start. And we start from the motivation. Firewalls and traffic in Yandex. It can be divided into these two big classes. First is internal traffic, which comes from service to service and inside of Yandex city. And the second is traffic which is vice versa. So I mean leave borders. And it appeared that the traffic is growing and internal traffic is growing not proportionally. So evolutionally firewalls has divided in Yandex in two big classes, brief and the boarding edge. So internal firewall regulates traffic of inter-service communication, and every source or receiver of traffic, there is small local firewall. Why? Because it's horizontally well distributed, and secondly, firewalling of tracking consumes processor tacts, and when it's done locally, it's very convenient service. So, but everything is good here. It's not subject for our presentation. There is second part of firewalls, edge firewalls. And external traffic is traffic which goes to wild internet. It comes through edge firewall, and here we can face scaling of problem. And technically this solution is software solution which is installed on the same hardware where other Yandex service installed, with the distinguishing that netcard is better and it's reserved, so usually 2 cards. And amount of this hardware is limited, and it means to summary of capacity related to firewall is limited too. Additionally to this scaling, it's not linear at all. Due to this peculiarity of realization of this software, it's interference between different classes of traffics. So one package can consume more traffics for processing. And it happens like this, then the other class of traffics will suffer. And we would like to continue to grow, to utilize 200 gigabytes and networking cards and look into the future. So, and we have faced the problem with 10 we can't motivate evolutionarily, and we need to do revolutionary things. So it sounds intriguing, but as far as component which can fail all Yandex, one mistake can collapse a lot. So here it's needed safe solution and upgrade firewall with downtime. It's even for 6 hours, it's not a cool idea. And let's consider this. What is the current firewall solution? There are different firewall firms in data centers which serves about 250, 350 gigabytes traffic. It's about 30 mega packages per second. And in the future, these numbers will be growing, and we need to be adjusted to this. And this solution, it's IPFF firewall. It's very familiar in Russian circles and other circles. Why this firewall is good? It's very good reading syntaxes. And it's very flexible, agile, and the same it can be weakness because we related to flexibility, and we face that we need to support the same format because no one would like to go deeper and redesign. So what about rule set? Let's look at this example. The first rule, HTTPS, traffics from one network to another. So the peculiarity of this, that it goes from top to bottom. So, and add allow TCP from. So, and the package will be consumed and don't go to bottom. But this is another more tough rule. So, and initial sources can be quite big amount of networks. Here we can see 2,500 networks. And the problem, if we take this rule and make it simple, we will have about 2 million new rules of simple rules, but it's very, very much. But these rules are majority of them, so it's about 40,000 rules of them, and if we redistribute them, it will be about 300 million rules. So, and peculiarity of P firewall, so it goes from top to bottom, and the order is very important. And of course, in role set, there is optimization through trees, from hash tables, and etc. And the biggest part of role set, it's linear, and it connect. So, and we need to improve, and hopefully for the constant time. And in the rules, we can meet networks with the following types. So with the amount of the bit in mask and open IP/IP, here it's quite simple. But in Yandex, the second type of networks more popular, wildcard networks in the internet. Why we need these networks? They're for organization inter-service correlation. So IPv6 address in the segments, in the lower segments, is coding unique identifier. And this identifier helps us to organize those rules. But why all the bits 0? Because they are in the several data centers and we need to make routing to work. So if we need to write a certain rule, that we write something like this. And to write algorithm for such networks, it's quite unpleasant thing. Because here we don't have a tree, it's graph, and it's not really clear what is prefix in it, what is longest, and it's not clear how to find. So we always motivation, and let's start with modern science and future. Let's start from the bottom. So the similar solution on Linux, it's IP tables or NF tables. I think everyone knows this. This is the same contract of like IP for web, but even worse. But the advantages, it's reliable, it's flexible, it's agile, but we need reliability. So 100 gigabytes cards don't help. And plus supporting local networks, so we don't consider it anymore. So the next option is more perspective. EVPN. What is it? EVPN. Let's say you write a program in such kind of dialect, then it make bytecode in Linux core, and during the stages of verification, and then this program performs in this core. Then it's achieved huge productivity, so 40 gigabyte cards, they can utilize it up to 100, but we would like more. Plus, we have some limits, and we don't want to accept these limits. For example, restriction because it's restricted on one page of memory. I heard it was updated for the previous versions. I haven't checked, but it's not the biggest pain. The biggest pain, to my opinion, is that those who tried programming for eBPF, they would agree with me it's very inconvenient and difficult because the compilator verificator is often out of sync, and it seems like valid program in terms of syntax and bytecode. They don't follow through verification, maybe because of synchronization or because of fiction bugs in the core, and it's very often happens, and assembly by code. So we don't need it. We need more freedom in development. So to tell it shortly, it's not software solutions, but we consider software solutions. So let's start our presentation. The main point of our presentation, DPDK. So this option is more perspective, is more interesting for us. It's not first DPDK application, and in Yandex it's already proved by years of its success. And DPDK helps to utilize 100 gigabytes and networking cards without problems, which is good for us. And what can be disadvantage? Okay, freedom in developing and programming, but for example, code can be locked in UTXO or page fault, or it can be cross-border not. So then you have delay when you in the memory, so drop faults. So that's why programming should be very careful. Okay, DPDK, Data Plane Development Kit. This is the set of libraries to simplify soft for the maximum production efficiency from hardware, and the idea kernel bypass. So the base. So you go to the core and tells, give us everything you have, and core gives you network device, and then you do by your own. So vendor-specific tricks and buffer cards and whatever you do. So in all these things, DPDK can just for us. So like there is buffer for you, do your writing. But here we face some many nuances. First of all, networking card is connected with PCI, which is pre-pinning to the NUMA, which is in the modern hardware. There are two of them, and in order to cross this edge, this is the main part of productivity. This is like heat productivity, and we don't need this. And we have two networking cards. The disadvantage is to use two cards. We stuck in PCI bus, and it's just increased throughput, but we sit on the 4. To utilize correctly our resources, we need to distribute it into the cores and the cards, and we need to build with a loop which we can make these packages to something and continue writing. But it's not that easy. Let's take network core, and it still tries to be multitasking. And this process of writing in the core, it will be due when it's needed or not needed, and because we have busy loop, it will harm us, and we need to tell recompilation, tuning call, to abuse, to write options, balancing, and etc. The next, SPU has characteristic to decrease the pool, and we will not have it. We switch on turbo, NL into and hundreds of options. Hyperthreading, no, we don't need. We switched off. AVX 512, my opinion, as far as for the Intel vectorization, and to use it a lot, it can decrease productivity and downloading. So it can come into cloud downloading. Because we fight for the frequency, we don't need this. But on the other hand, we can't guarantee that we won't have the application which will harm this. And this coefficient of downlocking depends how many cores included in this vector heat, and frequency can be decreased twice, and we don't need it at all. So what we can do, we switched off vectorization until compilator. So we don't need your code. We will write it if we need it by our own. And we need a lot of memory, a lot. Why? Because we need to store structure of data and extract when we need it. So, but we need memory and we need follower, and because we don't need to catch page cache misses and delays of locators and fragmentations, and this we select huge amount of memory and use it. So DPDK also has many APIs to simplify, so I skip it, you will read it later, and let's go to architect of our firewall. So, and the logical distribution in this application, this division on data plane and control plane. First is data plane that just exchange packages from one card to another card, and it's some kind of the core of the system, heart of the system. It's very productive, shouldn't be interfere in its work. But you cannot relax. There is something wrong. It's dropped, and that's all. The second one, control plane. That's doing dynamic improvement and control of its performance. Let's say it's brain of a system. And you can relax a little bit in terms of algorithm structure of data, but a little bit relax, because as you adjust data plane, as it will work. The task of data planes, to communicate with data plane, to adjust, to tune different ports, to write mark, labels, and etc. adjusting of tables of routings and BGP daemons and vice versa. So compilation as ASL and in the best way, and plus many things like aggregation of metrics, access to internal structure of data plane, for example, list of rules and of the every anti-count. So let's focus on data plane. As I said, the main task is exchange of the packages. So we cannot see traffic in Linux, but some packages we can forcibly send into core. So when there is BGP traffic, LGP traffic, so data plane doesn't know what to do, but Linux knows what to do. So it's just proceeded in the nearest BGP daemons. What happens in the start data plane? So first what we do, we initialize DPDK. So we have to do it from the beginning, then allocation of the huge amount of memory, about 100 gigabytes, and then we relocate the structure of our data, and then launch necessary workers, traders, and additional ones. So SPU numbers, and the second one. So, and the main pipeline of the processing packages in the first one, and some kind of service of the collecting of garbage when it's needed. And here, I think it's important to say that all configuration of data plane, it's stored in 2 copies. Why 2? Because one is when it's exchanged of the packages, and the second one, it's updated. So that's we serve as an update of configuration. So pipeline package processing. So every process goes routing in the eternal cycle. And this is the following stages. Physical port. Here packages launch from the network cards, then it's initialization, then we can send it to the core if in the specially developed by us logical port, speed up, debug, which we already deserve. And logical port, this is initial processing of packages. And here packages can be dropped. Why? They can be dropped. Imagine destination MAC address. It's not in compliance with the address of machine, and it will be dropped because it's lost its way. Ingredients, firewalling. So I will not pay attention to this. I have several additional slides to this, and here firewalling, decap. So they are not used in firewalling, so they are used in our other DPDK projects. So let's move to tables of routers. So with the rewriting of destination MAC address and send to the name ingress, ICL ingress, the next one after routing. So after routing, package can come to different rules, and some rules are marked with special options. So like here it goes, it's outcome, logical port. Logical port is preliminary finishing of package construction, package developing. So macaque addresses physical port, sending to physical port. And some words about slow worker, because it's quite important part in data planning. This is additional worker, which lives on separate core. And what it does, it's communication with control plane, and slow worker is IP server in itself. And secondly, it communicates with the main worker cores. Why? Because sometimes it needs to do something small, for example, to send packages into core, and it's done through slow worker, not directly. And thirdly, and one of the most, it's reaction on the environment. For example, IDSPDent on logical IDSPDs process these changes of flag and in workflow of packages if it's necessary. And of course, garbage of garbage. So, and let's move to the main part. What's going on with the packages which is in data plane? So we need, from all our rules we described, we need the most fast way to find the necessary thing, and we need to do it for this certain amount of time, because we don't need interference, we want to be stable, grow constantly, according to rules, and plus save order, logic of the order. But the bonus advantage, we don't have any restrictions in terms of memory. And it means exchange SPU time, and make compilation of rules. Let's consider 5 rules. Five rules. So let's this package of firewall. This package. Web people. And we can see it matches on 3rd and 5th rule. Yes, and we're human, we can do something fast, but machine has to learn what to do. That's why we need to formalize this logic of matching. And this is for the multiples tasks. So we need to find from all our rules, we need to find matching rules and to select the first one in order to keep the order. So, and then this task can be solved for the every field separately. And with crossing of these sub-multiples numbers, we can find final result in summing multiples when we can find the final rule when it's matching. For example, what we do for this? So we acquire the number for every rule using bit masks when every bit will in accordance with the rule, with the number of the rule. And then after this, we divide every rule into the fields which participate in firewalling. In this case, it's protocols, source destination network, source destination ports, and flags like fragmentation, RST, SPC nodes. They are not here, that's why I didn't put them. And after this, we need to build the structure of data for every field in order that lookup happens for the constant time. And with keys, it will be the meaning of the fields, and bit mask will be for the meaning of the numbers, and they will tell in which rules this field equal to this number. Let's consider the protocol. In all our rules, we have totally 3 protocols. And IP plays for us important role. It's a well-card protocol for a wall. If we select IP, that every packages can be matched. So that's why what we do, we build a massive with size 256, and every element of this massive we build a bit mask which consists of the rules which is matching in the rule in this field. For example, according to protocol IP, which is world call, it can be matched any protocol. So it means we send the latest 2 bits in every meanings of this masim. For PCP number 6, it's 1st and 3rd rule. It means cell number 4. I hope logic is clear, because for the source and destination ports, everything the same. It's more interesting for the networks. So what would we do to build prefix tree to organize prefix match. But here we are not able to do this because Welcome Networks complicates task. We need to build graphs, and the main characteristics the following. So every node includes the mother codes, and every mask in the node includes ICP of its parents. Why it's needed? It's to organize operation which is base match. There is package which has IP address. What we do, we take this IP address and follow the graphs until we match it in the best way. We take this bit mask, and as a result, for the given package, so logic matching is in the order of constant time lookup with the next crossing. What we have final bitmap when we can see packages matches in the first and third rule. And how to find it? We go on to the mask from the left to right, and we find first selected bit and first rule, which is matching. It's number 3. Simple, beautiful, but not success, because we have 40,000 rules, and bit mask it will be 40,000. And because we don't have 40,000 bits processor, it's pain for us, because algorithm will be working in linear time. How we can speed up this? Nothing to do. We can do only exchange memory on CPU. So what we can do, total in compilation, we can numbering every bitmap with the unique index. So it can be done in order. And after this, we need multiple decards in all possible ways to come to the final rules. We need build classificators from unique bitmap, and the biggest amount of such multiple will provide us empty bitmap. We ignore this, and the result will be huge table, which provides us the following algorithm for matching. First of all, we look up in the initial classificators, we get index and use it a key for the next tables, and then we get it until we come to the final numbers. So, and as a result, we have something like this. We decided not to multiple at once because it will be huge consumption of memory. It can be compilated up to the end of the world. And we have divided into phase. Phase are very simple. So, and we divide into files, multiple networks, and then multiple the rest of the things, phases, and then go.
The algorithm is called recursion flow classification, and all these structures are uploaded to data plane, and getting back about what ACL module is, it's basically a sequence of those, and that's what we wanted to get. So we have constant time lookup, and we wanted maximum efficiency, and we measured it. And our shooter wasn't able to DPDK to fully utilize DPDK. Eventually, we have created a new shooter, and we got 200 gigabits per second, and we decided to reduce the number of cores, and it transpired that it's up to 8 mega packages per core. So that's the 2-core shooting, and this is it. Oh, well, I must say that I haven't managed to cover even half of what I wanted to cover because of limited time, but I'll be around here and I'll reply to all of your questions. Thank you, Evgeny. It's a very interesting presentation. Please tell us at which state of implementation are you? Oh, we are already in production. Yeah, good. Well, I haven't been fired yet. Yandex has not tripped and so on. And you were talking about switching from free BSD to host-based firewalls, and now you are again talking about server farm. So what host-based firewall, how did it fail? Well, it's different. They solve different tasks. So you are covering external traffic on DPDK firewalls. Yeah, okay, got it. Do we have questions from the audience? Yeah, we have one question from online, and we have basically just 3 minutes. Did you use AMD? Well, frankly, we wanted to test it, but we haven't used it. We didn't manage to. But yeah, we have it as a plan. It's promising, especially given the nodes. Good afternoon. My name is Igor. I have a question. The following question. Do you understand that the whole procedure that you created and all this R&D started from the need to quickly process the pool cards? Is it a correct statement? Well, it was only part of the work that had to be implemented. Is it possible to acquire it, wrap it up in stack, and just give you the money? Well, it's not open source. We haven't considered it. Thank you. It's a great job. Well, we have a lot of questions, and we still have time to ask some. So the following question. We have a VPP implemented on DPDK, and there is a firewalling module that gives you a high efficiency. Why didn't you use it? Well, as I mentioned, DPDK, it's quite a big set of poorly connected libraries, and some of them are auxiliary helpers to create firewalls. We've tested them, and we were not happy in terms of their efficiency, and they didn't work with wildcards back then. Another question from the audience. Hi, my name is Vola, still. And my question probably requires a separate presentation, but please tell me, what do you do if you suspect that the firewall has damaged a package? In case of PPP, there's sampling, something can be restored. It's totally horrible. It's not possible to use it. So what do you do in such a case? Well, firstly, we have separate counters for damaged packages, and if we have the counters growing, then we start debugging. Also, we have another solution to track for damaged packages. Okay, the last question. Which size of package did you test? And so if you're in production, well, it's not about the size of packages because we're interested only in headers. Okay, with this, I suggest us letting Evgeny go. So there are more questions in the chat, so please take a look and reply to whichever you want to. And now we are having a lunch break. We have 1 hour to walk around, take a breath, and we reconvene at 2 p.m. and we carry on with interesting presentations. See you.
С обеда.
We are getting back from lunch. Please join us. We start with the next presentation. Please come inside the room or get closer to your laptop. It's very important to know what kind of connectivity we have. We are fighting the losses. We are fighting downtime. But it's very important to also understand external connectivity. What kind of channel do we have with our user? What does Yandex do in connection to this? Alexander Azimov, one of Yandex architects, monitoring lover, ETF member, he'll be giving us some information about that. Thank you for the introduction. It's a very unusual sensation. I think it's the first time in 2 years when I see so many real people instead of just talking to laptop. Well, hopefully we are approaching normality and there will be more normality happening. And I hope that you like my today's presentation, brand new presentation. And there I'll be talking about how we monitor and respond to the incidents with external connectivity. But first we'll start with some basic things. I think no secret that incidents happen. Quite often it's connected with somebody making an error, and maybe this somebody is outside of our reach and we cannot punish this somebody. And there are major incidents, minor incidents. Recently you've seen what a big incident looks like. But very often, instead of looking for a reason or root cause, they look for somebody to blame. And it's very important for us to look for the network anomalies, and we need the tools to show that it's not an incident with our part of business. And there are a lot of services that will be providing all kinds of monitorings for a certain fee. But now I'll be talking about services that do not require any third parties, so you can create them yourselves, or they are simply out there. You just need to start using them. So here we need to start with NEL. NEL, or network error logging. What is that? It's a fantastic thing. That's how it works. Your user is using a browser and it connects to a website, sends a request and receives a picture, for instance, and 2 HTTP headers telling what kind of errors there may be and who to address the errors to. And if issues happen, if there is no connection with the site or server, then it'll forward the information to the specific collectors, information on an error, but it won't just random information sent. It will be a description that it can be failed NDS, it can be a TCP error, it can be TLS. So this way you can not only see that some error occurred somewhere, but you'll be able to see at which state of request processing did the error happen. So here we have an example. We see what kind of request we had. It was GET. We can see this server that was addressed, and we can see all the information like distributed services and so on. And there is a type of error. It says that it's not just an error. It's a TCP error, namely TCP reset. What kind of browsers work with NIL? Well, basically all of them work with NIL except for Safari. We don't have Yandex browser here. Yandex browser is compatible with that. Anything built on top of Chromium supports NIL. So if you are service administrators and so on, you just need to add the respective headers to your replies to HTTP requests. And of course, you need to have collectors, preferably not where your servers are, to make sure you don't have all the eggs in one basket. I understand it's not naturally it's not too difficult to use a VM even in some client's place. An example which I find interesting. These are the TCP errors in one of our clients. So you see something happens on this date. Was it a network failure? Because normally we have TCP errors when we have issues with networks. The answer is yes and no. And the errors are appearing in case of mobile connection with poor connection quality. And the problem was that timeouts were set in a more rigid manner. So that's why the timeouts were happening faster. So to make a conclusion, NEL. I think NEL is really cool. And it's possible to distinguish between different types of errors and anomalies. You can differentiate between network errors and DNS errors and so on. But in terms of diagnostics and localizing the problems, we cannot point to where the problem appeared. And gold, or it'll be for tokens. And here you see an example of free/not free services like Graph Atlas. And it has dozens of thousands of probes. Is it a lot or is it little? In reality, it's very little because those probes are the global probes. And you may not be as lucky as to get the necessary coverage that you need. Well, we have a number of probes in Russia. We are interested in a connectivity of around 1,500 autonomous systems. And it won't be sufficient for us to get the RAP Atlas. RAP Atlas coverage is not good. RAP Atlas and like, they are good in terms of checking what's happening. There is like a big anomaly that crushes many networks. Then you'll be able to see the dynamic. But despite the fact that you have some options there, it's not possible to detect the specific link that causes problems. And you also cannot check outgoing and incoming traffic. So you have difficulties. And you'll stumble. And if you are a provider and you have a lot of networks, how do you create a system that will help finding anomalies connected with external connectivity?
So this is the wooden table. So this is Latin phrase, can be translated like Learn yourself. And there is different interpretation of this phrase in philosophy. One of it, so learn yourself. Learning yourself, you can learn about the world. So, and then think about this. What can make the simplest probes? They send request ICP, and we send them ICP and IP. But what if we invert the situation? So what if probe is not the source of traffic, but we will be the source of traffic? So if we reply the outside and collect the request and be arranged in the signal we receive, then we can get monitoring of external connections, and we totally restrict the limits of the probe. So we took data on traffic. We looked what autonomous system could be interesting for us. We took the map, which is utilities, which helps us to scan fast the space in those autonomous systems, and we found thousands of stable addresses. These are our samples. These are our tests. So, which is in our process of monitoring. Then we build the general list, which is about 1 million of IPs. If you show me external service, about 1.5 million probes, for me it would be very interesting to look how it works. But nevertheless, all these system sends to monitoring agent, which scans targets and conducts experiments. So we have several of them, geo-distributed, and let's look how it works. Let's look at this sample and the example of this incident. This is Megaphone network. It happened 2 weeks ago approximately, and this how we can see on all Megaphone networks have 10% of losses. 10% of losses. So system works. Moreover, we compared it with NIL. NIL not always looks the problem which we can see here, because NILs will report in the case when its connection is broken. Here, with 10% of losses. So in some cases, the connections can survive on BBR. So we have got system of networking monitoring, which easy to scale and which can make coverage. So we can make different coverage for us or for colleagues from Yandex.Cloud. And what is left? It was left how to name it. The only thing, we need to find a proper name. But there is a very interesting situation in Yandex about names. Of course, it depends the name of the ship. How you name the ship will be successful, depends on the name. So, and we need to find this name. So, and there are so different names like Fatality, Annushka, and etc. But we decided to be in trend, but quite simpler. And this is our name. It's very suitable for this name. This is from cartoon. So let's sum it up. What megaping gives to us? So it helps to detect network anomalies. And it's very good for scaling. But we still can't distinguish anomalies from the income traffic from outcome traffic. And we can't do it at once, and to find what link has defects. So it depends on the phase of scanning. So if we scan IPv6, I think we need to wait longer. And we decided we need more, we want more. We want a system which can cover this problem, which can fill this gap. And we have decided to look again at this pipeline, which our service have. And this is pipeline of package processes from incoming, from outgoing. So, as we mentioned several times here, our service of fabric doesn't have V4 connections. They need to cover project to the external IP6, name IP L2TL. So this is decapsulator device. It was mentioned. Evgeny Safronov told about it. It's one of the function of a DPDK platform. It's very easy function in this case. Get packages have 6 name, and then go to board and final lookup. And then the package coming to the client. And it's very simple, but there is obvious fact. In server, we have all information TCP info. TCP info, we have information on losses, on delays. So TCP stack collects everything. On the border, we have about the prefixes efficiency, and it's not that easy to connect all of it at once. It should be unite point, and we decided that our platform on DPDK can unite all of this and correctly process it. First of all, we decided to define how to get information from DCP to middle box. Can we calculate the middle box retransmitters? Yes, we can. Indeed, and there is nothing so complicated about this. It's just enough to follow a sequence number in TCP and then find TCP retransmit which coming into flow. So retransmit works like this. But there might be a problem. And the problem is about that we take only one streamline. We can see the number of retransmit, but we can't see proved confirmed packages. And here might be nuances. Not all packages without retransmitted will be delivered. So server can try to resend package and up to one moment, then close the socket. So it seems it sent it, but it's not confirmed. And this model we tested on 100% of losses, and instead of 100%, we detected 60% because some of them were lost. They were sent, but they were lost, and we detected those losses at the level of middle box. So, and it led us to reconsider the scheme, to reconsider the system, how to detect losses and how to inform our middle box. And here, TCP rescued us. So, you know, TCP options, TCP headings. So we know those well-known, timestamp. TCP fast open, etc., and etc., and etc. But although there is a secret level, which is experimental TCP option, which is for internal usage of administrative domain. So information can be inserted, valuable information can be inserted. And we did it. We took this 257 option and inserted information of number confirmed and lost packages. And on middle boxes, and we've got the number of losses of hosts, and then we need to get information about borders, control plane and data plane. So, and we wanted to monitor certain stacks and simple as. And the question was how to get it to the borders, to the edge. And because decops are not in MPS core, and we suggested it is a useful transport starting from host. That's why MPS and TPS, it wasn't an option. GRE, UDP, and more than SRv6. But there were questions, how this traffic will be balanced? Okay, probably monitoring won't be problematic, but if we have the main traffic on the same scheme, we might face problems. And here there are two fields, source port UDP and flow label in all variations on IPv6 modulation. So unfortunately, flow label, we are not ready to include at the level of DCI because there is problem at the links core. It can be included, but very careful in certain places, and be very careful because the session can be interrupted. And the only winner, MPLS over UDP. So let's learn what happens with this package on border. First, very simple, UDP package came on border, and we took heading UDP, and then look up, but it's not. Stick. And every joint is in table. Let's see the junction felt, and we have default for this case. And we don't have information that MPS label can be lost. This package can come in VRF, and there is MPS label and information to the general table. And in general table, we have all routes, alternative, and packages. And a result. We know how to deliver information on losses up to the decapsulator, and also we know how to transmit information on routers. And as a counterplane, we used NPLS, DGP, VPS, and PN. And there were no surprises. So, and we have changing of packages, and we had new headings in PLS over VDP. And of course, it's clear in Decapsulator we have total freedom how we do with the sending packages. We can send on any alternative routes, and it's very useful for us, and I'll tell you later how. And the precious moment, DPv6 should be sent on the same scheme towards Decapsulator. But unfortunately, it was one small problem, the same problem. We faced our favorite 100 losses. So when we send SYNAC on link, when it's total unavailability, our connections can't be installed, and we look on the losses in bytes. And that's why, because not to avoid these links voids, we have come up with this idea: SYN packet, data packet. So we added clear randomization during package generation. It's not 5-tuple, it's 5-tuple plus random. Even if it failed from the first time, he came to the joint with total inaccessible. Next time it can be successful. If it's only one direction live, then it will be installed, and the next packages will be randomized and will be sent to the all junction, even to the problematic one. And we start make statistics on retransmitters. Does it work? Yes, it does. And this is examples with 100 loss, which we observed from one hop from VAS, and it was one of the department of Tele2. All 3 links of Air Telecom, we observed 100% of losses, and at the links of Rostelecom, everything was good, everything was excellent. And as a result, we We built filters and covered this direction towards Rostelecom. Now example of Rostelecom, from which we started. Remember, it was 20 minutes, then something happened, and Megapin felt good. So, and the losses was 20%, but only on one of two directions. And these graphics prove this very well. We have one junction with megaphone without problems at all, and one is 20% losses, which is correlate. And then engineers solved this problem on this joint, and look, the signal didn't disappear. Because we are on DPDK platform, like we ignore BDP solutions, we send there our test packages. We don't send out traffic of users, we send our test service, and it continues to work, it continues to check if everything is good. And we can see incidents lasted in the first phase more than 4 hours, the same day prime time. And all this time we knew we shouldn't include it back, and users didn't notice it. Everything was good. And again, we need to find a name for this. So probably if we built this year, we would name it Watchman from the serial. So, but because it was earlier, we've got this name, Dr. Egress. So Dr. Egress, which is controls outgoing traffic. So what he does anomalies on integration on junctions. So if it's load 10 kilobytes, so then the coverage the same like on nil. So, and it works in IPv4, in IPv6, what the system cannot do. This system cannot send automatically the mails. So probably someone of you faced this when worked in automation. And we plan to automate this process, that is letters of happiness sent to you automatically. Why we do this? Because we believe that so happiness of users, it works of our network and your networks. And total summary, total final success comes into the final users' happiness. But there is one nuance from the incoming traffic, because incoming traffic, if it started to lose, we won't be able to see it, and it will be collapsing graphics. But we have two other monitoring. We have NIL, which can show anomalies, and we have Megapin, which can show incoming and outcome monitoring. So it means if we can see failure in Dr. Egress, mistakes in Megaping or NIL, it means definitely there is a problem of incoming traffic. So as a result, we've got a system of multi-level monitoring, which helps us to detect problems in incoming and outgoing traffics and to detect which junctions it happens. Thank you very much. I finish. If you have questions, I'm happy to answer. Thank you very much for your presentation. We can see there is a question. So, how long it took you to find this name? Not that long. Then I named Megaping. So initially it was Egress monitoring, but they told me, oh, it was boring. Let's find something funny.
Thank you very much for your presentation. I got the following question. Were there any concerns about the random victims? No, because we were as careful as possible. Because there are 3,000 packages a minute to the network, so it doesn't cause any difficulties for anyone. And we were not scanning. We used only the 80th port. So basically, you are looking for public services to use as monitoring agents. Well, we have the agent on our side. We were sending the packages to them, and so they were not aware and they didn't have any questions. This is the internet. Okay, thank you very much. Any other questions? Do you have anything in the chat? Thank you very much for the presentation. Could you stand up and introduce yourself? My name is Andrey. Thank you for the presentation. I have the question regarding megaping. How does it differentiate between Yandex incidents or the internet incidents, internet-related incidents? That's a good question. Clearly, it cannot differentiate between Yandex issues and the internet issues. But we also have internal monitorings. So that's why we can always decompose the signal. And if everything's well on the inside, then probably then the issue appears externally. So we can clearly understand where does the error come from. Thank you very much. Thank you for the presentation. It was very interesting to listen to that presentation. Hopefully everyone enjoyed that. Our next presentation will be about the following thing. When you have so many devices, then you stop giving them individual names and you start thinking about automation, you know how to replace the cards and send it to the vendor. So we have Viktor Osipchuk from Google. Very happy to welcome you here. The floor is yours. Good afternoon. Thanks for staying here for my session. Today I want to talk a bit about somebody's presentation. Okay, now it's my presentation. In Google, there are quite a few tools or systems which work with hardware, with traffic, and so on. And one of them is AutoRepair. An interesting thing is that in Google, some time ago, we used to name different apps in a funny way. Like 4 or 5 years ago, this policy was canceled. And if some new app or new service is being created, then we give it a name that'll be explaining the essence of this service straight away. So from here you can see clearly that AutoRepair is something about repair. Unfortunately, I wasn't able to get my slide deck in Russian, so it'll be in English, but I'll be speaking Russian. So I have around 30 minutes, and I'll try to stay within 30 minutes, and if we don't have the time for the questions, then please approach me in the lobby, and I'll be happy to reply to your questions, because there is so much to tell you about that. AutoRepair is quite a big system, and there is a certain core team in charge of it, around 10 people. And there are different people also involved, like network engineers who think that something can be optimized and so on. So first, I'll give a bit of an intro about that, and then we'll proceed to the system itself. It's clear that Google network is quite big. This is a slide for public presentations, naturally the network is much larger. So basically we are present everywhere. Huge connectivity, and given the amount of equipment and the size of traffic, it's very hard to do something manually. So almost everything now is automated. And another interesting thing is that around 5 years ago, the team that was in charge of network operations, basically these are the people who were sitting somewhere, monitoring or getting tickets if something happened. So this team does not exist anymore. So now we don't have screens with network with some reds, yellows, and greens. Of course, we do have monitoring system, but we don't have people for that. They retrained. So we don't have any dedicated personnel here. So what does happen when something happens with the network? And before talking about AutoRepair, I'd like to mention that there are a lot of networks in Google. We have a corporate network separately that connects offices. It's not a production network, so we won't be talking about it. Basically, it talks the same mechanisms and systems that are used in production networks, but normally they get into production a couple of years after. Initially, well, of course, we have data centers, Juniper data centers. It's a certain technology. So all the information you can see on the website is something that's available in different resources, mainly SNCs, and you can read a lot about it. So we have Juniper data centers, and they are interconnected with the help of a separate network B4 that connects them together. There is B2 network, the yellow one. That's about the internet too. So when you try to check Gmail or when you turn the Google Maps on, you'll be reaching for some data center through B2. It can be B2 or B4, but anyhow, that's the big picture. And the application that I'll be talking about is running in B2, and I'm working in the team or in department that's in charge of B2. And we also have different peering and different virtualization, like in Google Cloud and so on. So before talking about AutoRepair, I'd like to say a couple of words about what's our understanding of B2 network that is interacts with the internet. So when we are talking about Google B2 network, we imagine it as a entity relationship database. So basically, well, you being an engineer, you don't see it. You do not work with routers. You don't work with channels. You work with something abstract that represents your network. And if you plan to add something or to remove something, first you change it in the form of some intent that'll be transformed through different APIs. And it will reach the actual devices. And this happens at every step. For instance, we have designers who say, here we need extra boxes or something. So they create this intent, and it'll be generated, and the next teams will be and other teams will be installing that. And it's very important. So this is the state that describes, and here you see the example. So the router itself will be an entity kind. So we have this mode that's used not only by B2, but also by the corporate network, by B4. And there are around 250 different devices that can use them, and they are interconnected. So there are around 750 connections, so this is quite a large scale. And this is a basic example. So all the network looks like this, and whenever some change happens, then it's happening here, and then it's being pushed to a device. So we have a router, and it has some logical interface, and then there is a physical interface. There are some logical links forming a bundle and so on. So everything described like that, down to which port is in which panel. And all this is quite important because we have a lot of various systems that are used when interacting with B2, and all of them will be interacting with the MALT database. MALT was publicly presented in Santa Clara last year, and there were Jeff Noble and quite a known guy. So he presented all that, and he gave all the explanations, and there is a white paper on that. So I'd recommend reading that. So next, we have this entity relationship database, and we have a number of applications, and they are responsible for everything, starting from when a device is connected. Well, that involves a certain workflow, and ending with device decommissioning. And between those 2 points, there are a lot of different tools and subsystems that can generate the device configuration, that can transfer sockets or bands, draining and undraining services, and it's very important to have this database because other systems interact through that. And one of the systems that runs like this is AutoRepair. So if MALT is the abstraction for the whole network, then we can say that AutoRepair is the abstraction system for troubleshooting and fixing the bugs that appear in network, and it's done automatically. Basically, it's vendor independent. Well, there is a number of manufacturers for B2 network, and overall, the system doesn't care which device it is communicating with or which device it is fixing. Initially, AutoRepair appeared in 2016. It was quite a simple one back then. And currently, there are 6 libraries or modules that are aimed externally. So basically, these are the systems that will be interacting with specific people. We'll talk about that. And there are 19 components that make up the core of the system for us to be able to update our database and network with a whole bunch of systems that are of no or little interest for now. So how does it work? So let's take a high-level look. We have a certain device, and this device has a certain telemetry parameters. In 89% of cases, it's streaming telemetry when we have the information sent to different collectors, but it can also be a regular syslook, or if some vendor's platform does not support what we need to collect the information from the device, then it can even be communication like that. pinging certain box, requesting information and packaging this information to a database. So if an error occurs, then we have an alert system activating that will be notifying AutoRepair that something happened. And this something happened is defined with the help of certain library that can identify what can happen. So we're creating a pool of messages that tell us that something can happen, something bad can happen with traffic, with network, and so on. So all that is transferred to a decision-making block in AutoRepair, and depending on what's written in the code, a decision is made what will happen, whether it will be an internal action or we'll have to call the vendor. And there are quite a few scenarios like that. The most popular one is probably some errors with the line card. In Google, we log pretty much everything, every step, every action, every word. So all of it is logged and stored. And the same thing is happening with different tools. AutoRepair stores all the information about what's happening, and I cannot show you all this data now, but I can tell you that line cards cause the most of the problems, and the amount of time spent on fixing the line cards, it amounts to around 50% of all the repair-related work. So here we have an example. For instance, we receive an alert telling us that something's wrong with line card. Traffic drops or issues with telemetry and so on. So if it's the first strike, then in this scenario, the line card will be rebooted. Then the check is happening, success or failure. If it's successful, then we are done, and we are not interested in what's happening next, because if there is a second strike within a certain time limit, then something's wrong, and automatically the vendor case will be created. Next, when we have a vendor case, there may be different options. It can be either RMA or further troubleshooting. And when RMA is happening, we have the designated people who will be pulling this line card out. So you have to physically remove it and insert some new one. So almost everything is automated here too, and I'll try to tell you about that a little bit later. So a small part of the statistics that I was able to share. Every month we have around 100 events with line cards or more. And AutoRepair works on it, works with them automatically. Another regular error is power supply error, but usually it's easy. You just remove it and insert a new one. It's a little bit trickier with line cards. An interesting thing here is that in AutoRepair, you have priority grading. So the system analyzes the location in the network, which line card failed. So for that, it connects with this MALT database containing all the information on the network. And everything is prioritized. It can be P1, P2, P3. So all this leads to different response and different time of response. And all of this information is logged to be able to run an analysis. And we have like annual or annual meetings or meetings every half a year with the vendor, talking about why everything's so good or why everything's so bad. Next. In AutoRepair, there are, so to speak, three principles or types of abstraction. Interaction with the alerting systems or some network-related things like it pass towards routers. Like telemetry, or if you have to reboot the line card, or if you have to completely reboot the whole pizza box. So then we use the respective API to interact with this box.
So, if it happens that after a box the problem was not solved, there will be vendor communication. And in order not to send notification to an engineer and to say, look, at this device, the linear card is not working. So, for the everything which is in the network, there is a system, certain API, which is provided by company Google, and automatically it's a case created. And the third element, it's a vector. When we need to substitute linear card and there is data center or POP, and we need to extract it and insert it, and it might be people. So, not Google staff, it might be partners, team. So people physically can do this work. So, there is no need to provide access to all internal system, and it should be some level of abstractions for them. And also, it's important to understand that at some high level, probably it should sound clearly and beautiful, but there are some elements which you initially don't pay attention to. And it happened to me. It was a scenario, and one bad event happened, which is related to linear card, and it's related to traffic, and it, for example, a local script which is on the box, it can cover the linear card because we don't need to drop the traffic. And then during a certain time, alerting happens, and then we verify system and then tickets and workflow, and then it comes to AutoRepair, and it's not ours. It might be minutes, but so mold is database. It won't be updated. But since that moment when updated happened, something could, for example, change something. An engineer or a system, for example, they can repair something, some walk down. And inside of this database, so this linear card should be in up, but in reality it's down, and system upgrades it into the up, and our traffic dropped. So we can do that. Systematic router can make a flag not to take updates from mount system. Why? Because we need to have this stay, and when later when AutoRepair is updated in the mount state, then it removes the flag by itself, and there won't be accidental drops. And such scenarios, for certain amount of such scenarios, and we need to remember about them to come back to system, the vendor's connections. So we have API in order to create this case, and depending on what not just repairable fabric or linear card, and it can be team, organization, and case to vendor, and vendor starts to analyzed. For example, if vendor says, okay, so it can be repaired here, we will do remake here, they can approve this remotely, and then to send it to us back. Or it can be a situation when there is communication with vendor and we understand that we need to request remake, and there is UI, graphics interface, so which is used from companies' partners, those who don't have access to the internal systems and they don't need this access. So they have their own some type of abstraction. They just need to press certain buttons in order to authorize this process of remake. If, for example, if it's new incident, a new message of syslog, or something happened which we'd never known before, and for us it's interesting to understand where is the problem in order to fix it in the next release, we start communicate with vendor, so we reconnect, an engineer reconnect, as an not engineer, and in order not to waste our time to have teams, so then the vendor send, I want to collect 1, 2, 3, 5, and for us only needed to say, yes, you can collect these teams. Some of them can be very simple, automatically done, but some, let's say like engineer, RCE on a 10, it will be assess whether this command can cause a problem or not. Why? Because it happened already. It was done like this. So, and we don't need go to the box to launch, to apply to case, everything done automatically. It's very convenient. And during the process of communication with vendor, let's say, or when we just need to conduct such type of work, so production change request, PCR, created, and we done PCR, established with vendor, and there is just some kind of work needs to be done, and you request it, and you say you should done this work in that time. So inside, Command B2 has its systems when you can detailed describe everything you need. And from the outside, third parties, they have graphic interface, which is quite simple, and it will do callback for the internal systems and conduct the same checkings in order to trinity this box, and it won't impact traffic, no effect for traffic, and practice has proved it's very important to conduct these checks. And depending on the role, network location, volume, and for those people who conduct it, it's only 2 clicks. But inside it will be a huge amount of checkings, notifications, if it's necessary. And when physically we need to change linear card, it's done through workflow. It's quite simple workflow. So by technician, and when he has done it, in the end he said, I've done it through workflow mode. It will be updated. In order all the system should be in the same conditions like it's now. Google has pleasant rule. If you go closely and you see that something should be improved, it's always welcomed. It happened to me also. When I decided to improve AutoRepair, and it was welcomed in Google. I was supported. And here, this is just an example that there are certain models which could have been updated. And at the moment, nowadays, AutoRepair consists of several blocks, as I mentioned, and it's done correctly in order to use internal 19 components. Some of them are responsible for core things, which for me, as a network engineer, it's not really interesting to study detailed. But for me, it's interesting to know that this vendor of this platform, something better can be done. And for this, I don't need to understand total coding. Of course, it do exist, the code. But for me, it's just enough to finish writing a library, and then it will be integrated later. And to my opinion, so it's interesting how you can contribute to code. The first step, it will be a command which is responsible, a team which is responsible for this, who will control, who will check this code in terms of technicals. So that means, but after this, you don't commit it. You need opportunity to send this code for readability review. And an ls script, for example, in AutoRepair, it's written, it's coded in Google, and other languages are used in Google company. And there are certain teams consisting of quite big amount of people, mostly software engineer, those who have been specialized on codes. They're not network engineers. They don't understand in general about routings. They don't need this. They just want to be sure that the code is written correctly. So the language will be clear for the next engineer or not engineer. And that it will be consistent view. That you shouldn't be rethink about the library. So like this library, it was done by an engineer by one type of code, and you need to spend some other time in order to understand. And so for you, it's some kind of additional level of checking that this code won't come up in the negative consequences. But there are several points of view in different companies to this approach. And I like it. I think it's true, it's correct. So, several words about development. As already mentioned, AutoRepair, it's a product when it started since 2006. And it was time on the team monitoring networks conditions, and they decided how we can start to automate the work we're doing. Today, it's model architecture. There are core components communicated with vendors, communicated with the third parties. So in the next step, because at the moment the system is quite stable, and the next step is to use information which we already have and to try to make it more preventive. So, I mean, try to analyze and try to do something before it happens, before something bad happens. So it's very high level. So this is the future of the product. So here on the slide, you can see links to different components. So if you have time, you can read it. Thank you very much. Thank you, Viktor, for a very interesting presentation. Any questions? Viktor, thank you very much. My name is Yegor. I have a question on Malt system. Who and how interacts with the system, and as I understood, it describes connections. It should be formulas, it should be types. So how those entities, they coexist? So almost everyone communicate with them, our team, designers, engineers who implement it. So, but what's created, there is core team, which is responsible for design and for the formation. So the guy which is already mentioned, so tech lead, who was in the forum. So this is the team who stipulates how this mold should be look like. And these rules will be stipulated them. If you need to explain something, if you need to create something, you need to explain why do you need it. You need to prove that it's really necessary indeed, because as I told, there are many of them now. And if you need to add, let's say, something new, Nova Metro or new POP, actually it should be done through design. So because they use already existing links, and designer team will use an application, they say, we need such intent, we need that, and then the system, if it's proved, if it's accepted, the system will update that mall, and then the process started on developing and exploitation. So it's not just a web interface, it's requested. I'm feeling, yes, it's not web interface. So the web interface is for the commands, which is extract linear cards. My name is Evgeny. Good afternoon. I have a question. When I read mold on white paper, so it was told about MQ-scale backend. So what do you use for the storage this information in mold? So I wasn't responsible for the mold development part. As far as I remember, it was attempt to use graph database, but they failed somewhere. Something was wrong. I don't know detail because I wasn't in developing. I would like to, but I wasn't. And we have one more question. Thank you very much for your presentation. So the level where the system works, it's level of the linear card. Do we go down to transceivers or vice versa? Can we plan go up to substitute route totally? Yes, we all do have the level of transceivers. It's a quite fast reaction. And one more question more. So there was an algorithm of defining whether it would help, so it didn't help. So and you said the source of power, its change and the device. So the change of the power didn't help, but reboot helped. So it can be detected. Yes, there are different scenarios about the power block. Would it help to not? Usually it helps, but if not, there will be escalation on life. Yes, but if something is absent, it would be escalated and locked in the system. So if someone has more questions to Viktor, they can use a break and ask it. Thank you very much. Our next speaker, so network engineer, not the team Mail.ru. He will tell us about his project, Automation Mail.ru. So, automation we give to hands of an expert, Mail.ru. Thank you. Can you hear me well? Good afternoon, everyone. My name is Vlad. I'm developer and system architect in company Mail.ru. I work in department Mail.Dev, and we do monitoring, developing, and we believe in our department that in the nearest future, network engineering will be happily enjoy their future, and instead of them, robots will work. How happens, I will tell you. But from the beginning, let me tell you about our network. So, conditionally, we have division into different projects. ВКонтакте, Одноклассники, and Mail.ru, including services Mail, Search, Delivery Club, Uline, etc. So, all this deployed in different amount of service and demands a lot of access ports. And we have more than 6,000 network devices, but we continue growing, and we have calculated we have about 80 commutators per month, and the amount of setups is big. And before we had to do it manually, and during setups we faced problems, and I will tell you about them now. So, and the first and the most obvious one is time. So, because it took time, setup of one commutator could take up to 45 minutes.
And if we calculate labor intensity, then it'll take 10 days for a single person to work on the switches. Then switch replacement in case of an accident. If a switch is down, we have to urgently replace it. And what if it's live? We'll have to manually figure out a config. The next problem is routine. All of us like some creative task when you are able to do something nice. But unfortunately, this is routine. So setups were not popular in our department. No one wanted to do that, but we had to. The next problem is errors. Any repeated manual activities may lead to errors. They are also called human error or human factor. Try to create 80 copies of the same config, replacing the IP address. However attentive you are, at around the 60th copy, you may make a mistake. And I'll tell you what kind of main errors we came across when we had manual setups. For instance, a wrong IP address was added, or a wrong prefix was added, and that leads to an accident. Then, routing errors, it also leads to an accident. Or another case, when switches setup is done for the switch, but it wasn't added to monitoring. It didn't lead to an accident, but whenever the failure happened, we didn't learn about it on time, which led to an accident. So these are the problems we had when we were doing the setups manually. So we decided that we have to do something, and we decided to automate. So let us imagine a perfect process for setting up the switch without human involvement. The device is connected, it received the DHCP address, it managed to contact FTP, get back the configuration file, and soft, it managed to reboot, all the settings were applied, and that's it. Everything's done. So that's the process we were imagining when we were starting to create our system. We based it on zero-touch provisioning. Let me remind you what that is. Different vendors may have different names for this functionality, but the principle is always the same. ZTP is supported by Cisco, Juniper, Huawei, and Arista, and this is fantastic because that's the equipment we use in our network, equipment from these vendors. But ZTP functionality as it is won't help us. We need to cover the whole workflow for setting up the switch. It's working on the configuration, doing the uplinks, and running all the tests. Instead of reinventing the bicycle, we decided to check whether there are any solutions or implementations. We found some, but we managed that we saw that they won't cover all of our needs. And the main issue was that they didn't work with multiple vendors. We have several vendors, and we needed the solution to work with all of them. And having a separate solution for each vendor, it would be too labor-intensive. So we decided to write our own. So, allow me to introduce ZTAP. That's the name of our project. It can do many things, not only setups, but today I'll be talking about setup. So we split setup into several steps or stages that helps us manage the setup process. We can pause it, and we can skip some step when we have a customized setup, and we can roll back if we need some function to run again. So we split those into 3 groups. Pre-deploy. Here we do all the necessary tests before we actually run the process. Whether we are able to generate configuration, whether we have ports, and we back them up, we check the host names, checking the prefixes, and so on. And I want to talk more about ports. For instance, we have 2 aggregates, and we have 8 cards in each of them. And first thing that is checked by our system is the speed. If we need to set up the switch with those interfaces, then first 4 cards will be used. Next thing that's checked is the workload. When we see the card number 3 has the least load, and we monitor the equal load on all the cards, and the system will choose the 3rd card here. Symmetry, that's the next thing we monitor. We use symmetrical ports. So if we choose port number 1 on one device, then on the second device it'll be the same. Then deploying, interacting with the network. So we are setting DHCP, and we work on uplinks. Here I want to tell you more about DHCP. Those of you who were setting DHCP for different vendors, you know that these are different configurations for different vendor. And we decided to store this configuration in a unified format, and we generate for different vendors the configuration like that. The next group of steps is post-deploy. Here we run all kinds of tests before we let the switch go into production. But how do we understand that the switch has uploaded the configuration, applied it, and that the configuration that was applied is the right configuration? That there were no glitches. So we check LODP on uplink that goes to the switch. If hostname equals the host name we expect, then all these statements are true. It means that that the switch received everything, and this is the configuration that it is supposed to have. So as for the components, we have front end on Django and back end on Flasko. Front end and back end is not something conditional. It's having separate instances for redundancy. We don't allow our clients to back end. They only use front end and they communicate with the back end through API. So we need to keep somewhere those setups. That's why we used Postgres. We went for Postgres because it has API in MAC addresses in there, so we won't have to manually check the incoming data. Postgres does this for us. So we have our network, and backend communicates with it through a netconf. We try to not use bash and accept, so we use this popular netconf. And we have our new switch. We are communicating with it through SSP or something like that. So front end, it's implemented in Django, and UI has been implemented with help of React. Here you can see what the pool of switches looks like. So which step we are at, what kind of uplinks, what kind of ports are allocated for it. And we can also check the setup status. When we click on the link, we can check the log of what was happening with the switch. With the help of Django, admin console, we can manage the process easily, we can pause it, we can roll back, we can move forward, skipping the steps. And we have an interactive interface as a scheme of racks for us to be able to see which racks we'll be working with, and so on. Backend. Backend is done with the help of Flasks. We use Jinja to generate configurations, and we have an NC client to communicate with the network. Talking about configuration generation. We use abstraction in YAML, and we have access lists and datasets, switch model, switch vendor, and before running Jinja, we check our YAML abstraction. We look for necessary values. We input them into Jinja, and we get the configuration. That's what it looks like. In our network department, it's tradition that for the engineer to notify people in a chat when there is some configuration work happening. That's why we created a bot that notifies us of all the actions that's happening in production. Our bot is called a pug. It is run between 10 to 8 p.m. Monday through Friday. We try to minimize communication with production during work hours. So let's talk about the advantages of our system. The first thing that has to be noticed is support of all the vendors that we have in the network. We've also implemented the ability to quickly replace the switches. We support all of our internal projects. We are integrated with all of our systems, and we support two kinds of setups. We can set up with the help of management interface, and we don't have a management network. We can use the uplinks. But it didn't appear straight away like that, and we had a long journey. We started with manual setup, copying the configurations. Then we got a script that was generating config, and then we were manually applying it in the devices. Then the era of ZTP came. In the first version, we were using the functionality on switches. We were customizing uplinks, ran some tests. Second version of ZTP, we added nice web interface, integrated it with all of our systems, and added the quick model replacement functionality. And we have further plans, and we'll be implementing them for the robots to work. As I mentioned, this system has been running for quite a while, and I'm happy to share some results with you. If we had around 800 switch setups, we have 0 incidents. And switch commissioning speed increased 5-fold. For instance, the new role took us 10 hours, and now it's only 2 hours. Thank you very much, and please ask your questions. Thank you, Vlad. The questions? Hi, my name is Ilya. I have a question about DHCP. First question is why it's not Kia, but it's a simple question. Okay, good question. Well, it's used broadly, and we knew how to work with it, so it was good for us. My second question is about DHCP. How configuration is uploaded to the network devices? I mean, identifying the pattern, because there are some legacy devices, in which case you can send the configuration, and the flash drive is limited, and it won't be able to. This device won't be able to deploy it, and some scripts have to be created, and you have to send the script to the device for the device to be able to communicate the inventory system, requesting the necessary OS and so on. So how is it implemented for all the vendors? Because HTTP won't be good for all of them. Well, you have replied to your own question. It depends on the vendor. In some cases, the configuration is in HTTPD. In some cases, we specify the route for the Python script, and it's being uploaded to the device and is run there. As for flash memory, flash card running out of memory, maybe it's in case of the legacy. No, well, when we have enterprise, when we have some enterprise flash sticks. Well, fortunately, we didn't have such cases. Thank you. Marat, thank you for your presentation. I want to ask about NetConf. From what I understand, not all of your cases support conf, and do you use some workarounds or something else? Yeah, thank you for your question. I'd say mainly that's enough. In 99% of the cases, and conf is good for us. And we have workarounds, and in those cases, unfortunately, we have to have accepts. Thank you for your presentation. My name is Leonid. Tell us, please. You have your own IPAM system and a port monitoring system and so on. Have you considered Netbox? If yes, then why didn't you choose it? And if you chose it, well, yeah, if no, then no. Yeah, we use IPAM. We use Netbox. Well, if you talk about ZTP, anytime when we implement some system, we check whether we have open source, and if for some reason open source is not good, then we write our own code. No, you were saying that you have some inventory system. Inventory system has appeared before we got ZTP. We had it for a long time in mail.ru, and all the network devices were already there. And they were monitored and analyzed by this system, and all the logs are being accumulated there. Yeah, we had it in place when we started on ZTP. Okay, thank you. We have a lot of questions. And another question from Marat. I have a question of netcon state, and I'm talking about the hardware that works well. So, what about the configuration? Do you calculate and apply configuration delta? Thank you for your question. Let me think about how to reply to that. Naturally, before we configure something, we calculate the delta. We see what kind of diff we get, we analyze it, and if it's not harmful, then we commit. Okay, can I ask the question then? So you were talking about switch setup. After setup, do you have any kind of acceptance tests that check that everything is indeed okay and that there's connectivity and so on? Yeah, I think I mentioned it in my presentation. We have a lot of tests after we have finished with the switch setup. Before we start routing, we check that everything's fine. Yeah, it would be nice to learn more about it, and we hope to see you next year.
So it depends on what. So about what we say, if we mean Yandex automatic system, totally it's divided in two stages. Engineer, which is smart hands, he does press it up, and so it means activate, traffic incoming, and traffic engineer. This is the same team. Totally automatic. It's up to what level? Leaf, spine. No, there is no border router. So all fabric devices. So I have learned today many presentation, amortization, RP. So what's the future of network engineers? Great future. So it would be interesting to be with networking. So many great projects, so many things to do. Thank you, Vlad, for your presentation. So now we have our break. So we come back in 4:15, and one important information. So don't forget, in the evening we have our party. It will be not here, it will be in Frank. So everyone invited. So please come to party in the end, but come back after break and 4:15.
Друзья, начинаем потихоньку возвращаться.
Dear friends, so we come back from the break. What we can do when you have very complicated network, you have many routers. So with this overview, Boris Khasanov, architect of Yandex, he tells his presentation. So what ITF has, what vendor have, and why it's not always the same. Good afternoon, Boris. Thank you, colleagues. Thank you, everyone who gathered today together live and those who watch us remotely. I respect you all for this. Dear colleagues, today in this half an hour, I should be able to tell my presentation. What I'm planning to tell. These are three parts. First part is theoretical. So what does it mean? CR policy, the advantages of this, the additional advantage, why we are interested in it. The second part, the real situation, which we discovered during testing. And the third part, related to questions we haven't found answers. So we just see potential ways, but don't do practical things. So I have my presentation in English. And I will present in Russian language. So let's get started. So, what is a segment routing policy? It's quite an interesting question. What is it? And why we need to think about it? Why we need to test it? And of course, we need to mention the basis of technology, segment routing. And I think many of you who watch us remotely and many of you who are here live, they have heard a lot about vendor presentations. And we last year, you can see link below. So we made review what is segment routing, why Yandex is interested in this technology and plans to implement it. Of course, I will not go deep on these base things. I won't repeat what is segment ID, what is segment in itself. I'm sure majority of you know about this, but the advantage which provides this technology. So let's remind one famous marketing vendor. Segment routing is technology of routing of the sourcing. It describes network state, and we don't need to support this state on IP routing. And it's described in our incoming index PM. So added to package, and our way is describing on the source. So we don't need foreign state to support and routers. This is in terms of automation. But so next hope, we made presentation and told how we use traffic engineering in our networking. So based on RSVP and now we are in the process of migration on the segment routing, and we need this substitution based on RSVP. And of course, we have to consider new technologies. So, policy of segment routing. This is the enhanced mechanism. Provides much more capabilities, which we found very interesting and perspective. So we have draft at the moment, draft of standards. so which describes the app policy architecture, and it's very dynamically developing, and capabilities related to this technology probably not very mature. I will mention this in the next part. So you can find these details in draft. And the key point, if you see what is a segment routing policy, so how to stipulate. So it's important to compare with the classical SIPTE. So it's classified with 3 parameters: headend, incoming router, so where this policy will be provisioned, where it will be used. This is called, this is very interesting parameter, and it helps to connect our transport, these tunnels of LSP in certain LS service, so which is some targeted function in the future. Intense, remember our colleague from Google mentioned. So this is some kind of next future generation step in some policy. And of course, endpoint, up to what point we have to reach in the future network. So these 3 key parameters describes this policy, segment routing policy. And it's very important to underline that so inside of this policy there is hierarchical entity. So we will see this on this slide. So this candidate path, that's very important component in segment routing policy. What it gives to us? So this is policy represented in graphs. We can see hierarchy, which is a policy which is identified by this written headend. And inside of it, there is a set of possible candidates. It can be a numerous amount from one to other. So who can give us? We can get it by different ways. On this scheme, I wrote external entity, and I wrote this controller. This is candidate path. So the main vendors who support this technology has this. And this candidate path has variety here. It can be explicit, so like traffic engineering, and through which mode we can go through. It can be dynamic. And for example, somebody told us which way to follow. Let's say it's external entity, like controller. And this way can be changed with time. And this controller believes it's optimal to go this way, or something changed, we need to go that way. So it can be many cases. And the third option, candidate path, it can be composed. It can include inserted SAR policies. It's more complicated option, and its practical realization is not good. I'm just mention it. So, but who provides for us this information? We can get it by different ways, as I said, by configuration, which is first option, and we can get it through different types of protocols and APIs, which is supported on routing. So it can be path computation element of protocol percept, or it can be multi-protocol HTTP SAR policy. So it can be protocol origin or protocol weight. So the route can help decide which is more priority. And candidate path, we don't finish our hierarchy. So this is segment lists, segment routing, which describes certain path, and such type of segment list can be more than one. So we'll see it later. So this inserted construction looks like Russian matryoshka. So every way of this candidate path has contributors. What is characterized of originator, those who calculated this candidate path, who created it. So let it be router, let it be controller, and tells to us discriminator. So this is the digital number who will distinguish these candidates, because there are several of them and we need to distinguish them. And preference, the third important value, which describes the priority, which defines the priority, of course. Again, there are many candidate paths, but the active one in this certain amount of time, there is only one. The others, we can say, just back up. They wait for their time. So if something happens, let's say one segment list became invalid, then candidate path disappeared, and the new one inserted. So this is the logic of work. And this can be compared with the classical engineer, where it's simpler in terms of organization. Very important thing which we need to tell. So this is binding seed. This is special segment which is used in segment routing, and it's functional. So one of its application is to use it in segment routing policy. We can use it in order to tell router which traffic insert in this particular policy. We will see it later. And this is key moment. How to assign this binding seed. This is problems of different label spaces and different vendors. This is the same. Different vendors have different range of labels from which we need to select this binding seed. So as a rule, majority of what we started it selected segment routing global block, and there is global and local one. Local is unique for every router. So as a rule, it's assigned from this local one. And this is binding seed. It's transmitted to router and B seed. It's important how we get it because there are some nuances. If we look at this model, like this, the model of simplest policy, how it's described in this slide, you can see this is matryoshka construction, and the policy head endpoint. The next binding seed, which we just mentioned, priority, color, name of policy, and the next level of hierarchy, this is candidates. Here we can see only one, but there can be several of them. And here we're limited not by segment routing policy, but we are limited by mechanisms. So characteristics, as I mentioned, and segment list, which is describing the certain path in its side. These are important parameters, and I underline the most important, weight. So it can be different weight in terms of one technology. We can equal cost multipath balancing, or it can be weighted multipath. but there are nuances in terms of implementation. So, okay, we have spoken about hierarchy policy. We have spoke about how it's initiated, and we have this segment lists, how we transmit it, how we make configuration, and this is first option, and I will not mention it in our presentation. So as far as CLA, everything is clear. So every vendor has its own. It can be done separate presentation. That's why we skip it. So we have two main mechanisms. So which is supported by different vendors, PSAP and BGP as our policy, and PSAP. So in first question, what is to select among these two options? So, and we don't have the only one answer for this question, as it usually. That's why we need to consider both options. So in terms of BGP as our policy, protocol BGP we have been using for a long time, and we have decided to extend it in terms of supporting hierarchy. So here you can see BGP update, just for references. So, and here we can see three main pieces, because always, as we know, devil in details. The first important element, which is standard BGP attributes, we skip them. What we need to pay attention to, attribute which is called tunnel encapsulation attribute. Deal with where we code our policy, SR policy. What we can see here, binding seed, preference, all those parameters which we've seen, policy name, priority segment lists. So we have those BGP update, has to describe all our SR policy which we need to transmit, and there is an important moment where we practically already step in, and it's important to plan when we have many devices, PE devices, and you need full flashlight between these PE, and you say, let's use BGP for some reason. And we know that BGP has restrictions for the amount of messages. The more we have segment list, the more segment labels in every list, the longer message. So if we go outside default 496, then we are in the gray area, because moreover, this update won't be sent. And here it's important to look whether you want to support it a longer volume of BGP message and tunnel encapsulation attribute, where a SR policy is coded. The next important thing, it's our extended community, which we have here. And here one is very important, caller community, special community which stipulates color of SR policy. So due to discover color community index PE, so certain targeted functions should be inserted here. So our PE should be sent in our Egress PE, BGP update, BVN N4, and additional color community. So that's how we signal in the traffic. We insert in SR policy by this certain color. These two main key components. The next way, path computation protocol.
This is even more mysterious thing than P2P, and I think this is most important for those colleagues who are customers, but it's also very important for vendors because they need interoperability. And when we have RFP, when we have PSEP support, you need to specify what kind of PSEP support you need from the vendor. Because if you just say that I support PSEP, then it won't work. Because there are different objects, quite a complex protocol with scalability and object sets and so on. And if something does not work together, then the session is aborted, and this is it. So, speaking of interconnection, we need some external controller that calculates the routes and creates a list of segments that we need to tell the router about. So, why do I have all this? Because there are two very important messages we see here: PC initiate and PC update. It tells you about modifying those parameters or initiating the parameters. So you have to pay attention to them. Secondly, within PSEP, there are devices signaling about their capabilities. So for SR policy to work, you need to have at least two capabilities: stateful and SRPCE. It means that this external entity, this controller, it doesn't just calculate some LSP. It also stores them without the database. It's engineering traffic, and so it remembers what kind of LSPs were calculated. At the bottom, you have the links if you want to have a more detailed look. I recommend you starting from Adrian Farrell's PC tutorials. He is the most advanced guy in PSEP development, and he explains everything clearly. So, what we have to pay attention to in real life: C initiate, when we explain to our router what to do. So, we need to have a list of objects. This is stateful PC, and here we communicate the key message that this tunnel has to be created using segment routing. And here it's LSP, where we can convey the name of the policy and so on. And this is the end point. This is where our policy should end with. And of course, we have a source. Explicit route. This is the source. It's also very important, and we describe the list of our seeds, and we need the type because PC initiate won't run without it. And last one is the most magical object that may appear if we talk about delivering the policy through PSEP. It's the so-called association object. If we don't have it, then you can just say goodbye. Probably it's not supported. The PSEP won't be supported. So in this association object, we have extended association to B and the main. So what's difficult for PSEP in terms of sending this policy? PSEP was created to send separate ones, and we need to put them together and create a single entity. And this is exactly the thing that allows to connect all the separate blocks, and there are a lot of interesting nuances that we are going to talk about later. So, briefly, how do you work with the traffic in this SR policy? The simplest way is to use a binding SID. What we need here, it means that there should be traffic with the metrics, and it'll be able to see that, oh, we have a SR policy, and I throw this binding SID away and I replace it with this segment list that I have to send this package according to. So it's quite a simple way, but it requires labeled traffic. That's why per destination traffic steering is more popular when we have some service like VPN, and we have some package coming to the VRF, and we have a router with Xcolor community with list of segments, and the router understands, yeah, okay, I got this package through attachment circuit that it's some VRF. It means that I need to put it in a specific VPN and use specific SR policy, create a resolution, and send it. Another option is per flow steering when we have incoming packets using different policies and policy-based. Redundancy is organized in an easier manner. Even if the whole route is off, the second one becomes active. So we are coming to the end of the first part. A wonderful technology. It allows to achieve so many things, and we wave a magic wand and we'll become very happy. So we have the segment routing policy manager that receives everything and analyzes everything and so on. But do we have people who believes that this is the actual reality? Yeah, okay. We have the believers, but we have the severe reality, and we are coming to that. The reality appears when we have a multi-vendor network. And we face the reality, and we have these beautiful cats, and they represent different vendors. Well, we are checking for 5 vendors, but I found a picture with 4 cats only. So, due to certain considerations, we don't give the name of the vendors. Random letters that doesn't mean anything. Totally random, but we all know them. So we have 5 vendors who we respect very much, and we have group 1 of vendors A and B who are definitely in the 4, and they support both types of SR policy delivery through BGP and PCEP. And then we take a deeper look, and when we send our name of the policy, they replace it with their name of the policy, but it's not a strict requirement. More interesting thing is that the first vendor doesn't use association object described in draft, with the help of which we connect the CEP items to a single entity. It uses its own due to a certain reason. So that's why these 2 vendors are not directly compatible with each other. Second vendor does support the association object, but it uses private TLVs within. So if you take a look at the graph, we will see that there are different TLV names and numbers. They promised to fix it in the near future. Right. So we can assign the weights to those segment lists, especially when we talk about the weighted TCMP or balancing. These two vendors do not support that as of now, and it's connected with a deeper issue that we can discuss offline if you're interested. As for BGP delivery, well, it works more or less okay. There are certain issues with configuring equipment, but nonetheless, it works. And I want to highlight the fact that if you are going to consider this technology and consider different vendors, well, I told you about the calculations of the number of segment lists that we can send, and there was this BGP limitation. But in a certain situation, we may come across the limitations on the hardware side, because normally those segment lists are interpreted as different hops, although they may have same endpoints. And if there are many of them, we may well be outside of the limit of net scopes supported by specific hardware cards. But in terms of traffic, it works okay. And we have the second group of vendors, 3 vendors. Neither of them supports BCP. That's the key characteristic of this vendor group. But they support BGP. Oh, sorry, I don't want to hurt 2 of these 3 vendors. They support BCP, but they support that for simpler traffic engineering. But they do not support this association object for SAR policy. So let me correct myself, not to hurt anyone. So this is the number of segment lists that they support. And there is an interesting situation. One of these 3 vendors, when we send the BGP update, when we have policy name, it ignores it and it doesn't assign its own. So if you check the commands, there you'll see an empty field. You can have a lot of policies, but they will be nameless. So an interesting question comes: how will the people be monitoring that? So they cannot identify those policies. And one of the vendors has a very complex line, but okay. So I've created this table. I'm not sure whether it'll be of interest to you, but due to certain reasons, we cannot give you specific vendor names. But here we have the summary of what I've been talking about. Maybe it'll be useful for something. And we are coming to the end. So what do we do? What should people who want to use this advanced technology do? Well, we have this Rubik's Cube, and we have to kind of assemble it. Naturally, we cannot make all these vendors to come to similar functionality, because the key question here is, show me your money. If colleagues from Google or Facebook come, it's one thing. If somebody else comes, it will be a different story. So we decided to follow a different path. We decided to develop our own entity, our own controller that will be taking into account these specific features of these vendors. So currently, our controller is a prototype, and we are testing it with our vendors. And the last slide contains certain questions that we don't have the answers to. So we were talking about, what's the SAR policy? It was beautiful candidate pathways, weights, and so on. And you have PCEP and BGP as two ways of delivering the information. But it doesn't mean that everything's nice, because neither of those protocols, specifically BGP, neither of those guarantees that this policy is provisioned and that it contains the traffic and that it follows it. And we had certain cases when we had like black hole cases. Nothing was working. We have some ideas how to fix it. Is to have telemetry and monitor this policy. It's not BGP, it's a PCEP. Maybe there'll be some other technology that will help monitor what we have provisioned. So that's the key thing that we'll have to fix. With this, I conclude. Sorry, I was outside my time limit. Thank you. Thank you. Unfortunately, we don't have time for questions. You can find him in the lobby and ask him questions through the chat. So we move on, and our next speaker has enormous experience working in large companies like Cisco, Huawei, and so on. Now he's working in Facebook, and he'll be talking about history of backbone. Andrey Golovanov, please welcome. Good afternoon, dear colleagues. My name is Andrey Golovanov, and I'm a network engineer in Facebook. And I present the organization that develops and operates inter-regional network of Facebook.
So first of all, we start with the most important one. From behalf of the company, Facebook company, and on behalf of the my organization, I tell sorry from this scaled fail which happened on Monday this week. That shouldn't have happened. So and there are no hidden meaning in this. Unfortunately, these are obstacles and particularity of the systems of implementation. The details of what happened, it is already public. You can look at them on our blog of our company, engineer blog. Of course, we learn all the mistakes from the happened event, and of course we will minimize the probability in the future, the probability of such event in the future, and of course we speed up and improve of services in case of incidents. So, but now we discuss backbone of company Facebook, and I try to tell you something interesting. So we start with overview of backbone. So details of realization and component plane, data plane. So release engineering concept, which we use when we work with our regional network, and advanced task. Look at timeline of how we achieved what we have now, and how we started our beginning. So we start from the regional network and why it's needed. Why it's needed, of course, it's clear, because nothing works without it. Why does Facebook need a backbone? Backbone interconnects points of presence and data center regions. So points of presence are distributed all over the world. So when we mean typical communication between our services. So users of our network and internet, so coming to our services, they use DNS in order to get IP address of assignment, and this IP address is located in one of the point of presence. So here's box some kind of magic selecting the best presence of point, and then the session of and then from the point of presence it's sent to the processing center. So let's look at our data groups of data center data center regions. This is very scaled premises, as you can see. So scale means so this data center region, it's located in one geographical location. It's about thousands of megawatts of consumption of electricity. So it's more than 10,000 of stacks, and there are many of such data center of data processing distributed all over the world. We sell tens of them. Tens. So in terms of geographical presence, this is North America, it's Europe, Asia, and all those data center processing data united by regional network. So we can see this is thousands of kilometers of fabric, huge amount of sub-sea cables, and it's complicated infrastructure. But what we discuss now, it works over this infrastructure, on the top of this infrastructure, and use resources of this infrastructure. So overview how it's done in regional network. There are three directions: data center processing data, point of presence traffic, and point of presence, between point of presence traffic. On the first picture, remember it was arrows in the certain scale. So in the correlation between those demands, we can see on this graphic our traffic. So higher than traffic of points of presence and data center processing data, and it's growing constantly. And we need solution on big box, which is scaling on the growing demands, fast growing demands. So which will use effectively this capacity, which we mentioned, this subsea cables, this huge amount of installed long haul capacities. It should be used very efficiency because it's expensive resource, which is most available. And if we want to recover from incident very fast, and solution should be reliable and simple in the same way. And this solution is unified backbone architecture. This is so let's look how it looks like, the conceptual unified backbone architecture high-level overview. And here we can see that interconnects and consists of several components. They are Express backbone. You probably heard about it because we performed different presentations in different conferences. Express backbone architecture. It's our main network connecting data center. Data processing. And now we have new segment. We extend architecture we used in Express backbone. We express it to the segment of coverage point of presence. Here you can see access backbone domains, so which using the similar domains and connects data center with the points of view. In terms of high-level architecture, Express backbone consists of 8 planes. At the moment, it's 8 independent parallel planes working under controller management. Controller is independent for every planes. So these are 8 controllers. Every controller resistant. Several instances of controller working in the hot reserve. And domains, reserved domains. So as you can see, we didn't use multi-plane architecture for backbone because there are obvious reasons. Of course, it's good to use planes when it's possible. In Express backbone, we used 8 parallel physical planes, which gives significant advantage in terms of resistance, in terms of perform such modifications which is possible to conduct on devices. So, for example, transitions in terms of IGB protocol. Planning access backbone, we have to consider physical accessibility of capacities. 8 planes demands 8 times increase of necessary capacity at the level of transmission, system, and it's not possible in every region. For example, if we mean Asian regions, we have to use an architecture, but we don't use plane. So, and let's move to reality and discuss aspects of network design. Let's speak about control plane. We already spoke about parallel plane, and we already found out that it makes our life easier. In terms of scaling of protocols and routing, it makes our life is easier. So in terms of links inside of every plane, so and it's 8 times less than if we would have connected it into the network. In terms of control plane, so we use a typical classical architecture, which you could see in communication operators, and we have operators which distributes mostly UPEX, which is for resolution BGP protocols. So all routes which has traffic, they're distributed by protocol BGP. It doesn't matter of every plane. with every domain of protocol IGP, because planes are not interconnected in protocol IGP. Plane has its own IGP mesh and its own autonomous system. And significant factor which simplify the scaling of all network is that we don't transmit routing information internet through our internal network. So there is nothing to do with this internet routing. So it's 14 includes in these points of presence, and you can understand how it simplifies life of network engineers in terms of scaling of those protocols. So control plane, which we discussed now, it helps us to build in form of table in our routers. And as we can see, it will work without controllers. And we can see that we send through protocols BGP, and we get IPv4, IPv6 in forms of table in our routings. In terms of disappearance of controllers, everything continue working. Or in case when network recover after an incident and there is no controller, so the same situation, we have connection of network. We don't have a problem like hen or chicken or egg. So it's very important. It's supported and it's implemented by QoS, so the quality and maintenance. Our services distributed on the traffic classes. So mapping in the classes, and it's servicing on the routing. So it's being performed with strict priority in terms of classes. So if we have burden, first of all, we will serve control plane traffic and gold traffic. And the next, according to the classification. Again, it simplifies situation during recovery after incident or in case. So if it failed more, then it's could be in terms of fault tolerant. So many apply this model. So 75% promised, 25% capacity can be extended extracted from the services without any complications, without any violations for traffic demands. We can totally serve all traffic demands, extracting 25% from the capacity of services. So we move now to the controller part. Now we understood that everything could work perfectly without controller, but now we need to understand why we need controller, what type of tasks to serve. Two main tasks: traffic metrics, traffic engineering, and protection from network defaults. So if something in some direction fails, we need to move traffic to this direction. These two types of task control can solve, and which type of components controller has. In order to solve these tasks of traffic engineering, we need to know graph city topical graph suite, and we need to know matrix of demand, pair of source destination, and how many traffics between those pairing, source region and volume of traffic. Then we need programming component which can solve this task of demand distribution on this graph, and this programming component has to comply in the structure which will be understood by the equipment. So this is the main idea. And how it realized? It realized the following way. Of course, it's simplified. The diagram is very simplified. The ecosystem of those services which are inside and outside of controller, but it's good enough in order to transmit the main idea. So we can see controller services. There are two main of them. Traffic matrix service. This is the service which collects demands, which collects matrix of demands and transmits it to the matrix of controller. Controller is a programming component which decides the optimal distribution on these graphs. This programming component has to get this graph in itself, and this graph we get in terms of two components. First, it's our desirable graph. Desirable graph comes from the configuration, and we have to add it on our desirable graph the real available graph in the network. And as you can see, this blue arrow coming from the devices, we collect active topology from opener agent, open agent from our HB protocol working on the device.
Once we've collected this information and got the result, it's compiled, and that should be sent to the device to ensure forwarding. And these data structures, it's LSP which are sent to LSP agent, and these are static routes that indicate LSP groups that are sent to the route agent. And this is the way that we get data structure in our forwarding plane on those routers. Every 30 seconds, a cycle happens from straight away. Again, these data structure are forwarded to the devices, and that happens every 30 seconds. And if something happens in the network, then the active topology changes, and the next decision that will be forwarded to the device, it will be taken into account all the changes in the active topology as of that moment. And it's important to note that these data structures are supported via hard state. It's not a protocol like BGP that creates the so-called soft state. So, for instance, we have BGP session, and we got routes, and the session dropped, and routes have dropped. No, here it's a hard state. It's programmed on the devices. It doesn't disappear. So basically, there is no session that should be supported between the controller and the devices. You can restart the controller easily, or there can be switch between active instances of the controller, and it won't affect the devices. You won't have to restart certain sessions. So it's just the next controller instance will program all that. We have Thrift APIs, which is quite convenient, both for the developers and for the operating company, because you can always easily check what the state is, what objects you have, and you can just use Python and work with them if you need to. Right, let's take a closer look at that forwarding state. And let's just bring together this whole structure. Let's take a look at how it works. Let's imagine that we have a BGP route with traffic that carries traffic. And the idea is that the packets have to be transported using these prefixes. So destinations are matched against this address 2001/64. So we transfer it from data center 1 to data center 2. As a result, we receive a forwarding structure, and in the forwarding table of the router will get this kind of prefix indicating a subgroup that will contain the OSPs programmed by the controller, and they are implemented in the form of a segment routing stack. So what does it mean? It means that we have interfaces indexed with the help indexed in the network, and specifying the PLS tag, we can tell how our packet should go. To regulate the depth of the stack, we use binding SID to not exceed the depth of the stack, to make sure that we still can have per flow balancing in transit, to make sure that the routers can look behind the stack and can balance TCP UDP flow. So we limit this depth. We introduce binding SID binding our packets. So that's how we can go through the whole network. So in our previous presentations, we were talking a lot about the tasks of traffic engineering. Important thing to mention is that it depends on the traffic classes. We can have our optimal goal using the available vessel that's not directly on the way. And of course, controller is better in terms of distribution compared to the distributed or regular system. If we talk about some classic traffic engineering, and there are thousands of routers within one domain, and there is strongly connected graph with corridors, big corridors for traffic, like underwater communication cables. So when the cable is down, you have a transition period starting that when there is competition for the capacity that's there, and we have congestion in the network for a long time. But when we have a centralized approach, the controller places those demands in an optimum way, and there is no competition. There is no competition between LSPs, and that's done. To tackle the second task, preventing the downtime or crashes, we use path protection to avoid failures. We use protective LSPs, and they are programmed by the controller straight away. So protective LSPs, and they are activated independently. So if topology changed on the main path, then protection LSPs will be automatically activated and autonomously activated. So let's briefly talk about release engineering. We see that this is quite a complex system. And when we have a system, when we have software, quite a lot of software, in this case, we need to have a reliable continuous integration and deployment system. So we need to ensure continuous integration and deployment of these pieces of software. So our target is a 2-week deployment cadence when we need to be able to completely update our backbone. We are talking about hundreds of routers and thousands of channels. So we have a 2-week cycle for full, complete update of the backbone. And to ensure reliability of the system, we actively test and validate, and we validate in lab environment, we validate in shadow environment. This is an environment that's very close to production, but it's not production. Yeah, we have segment of network that's built in the real world, and it's parallel to production backbone, but it's used solely for release engineering to test and to make sure that the update won't lead to network failure. Right, and let's quickly talk about how our backbone was evolving and how we got where we are, to where we are. So we started our transit to backbone in 2014 when we just got this idea. And of course, this idea was a response to the needs that we got. And we discussed the needs. It's impossible to ensure optimum traffic engineering when we have a distributed network that's also growing. So by 2014, we got a lot of issues. We had to move on to something new, and we had to tackle the accumulated problems. So then this idea appeared to use Express backbone, and we moved from the idea to prototype quite well. So we got this idea in September, and in December we got a lab prototype. And in 2015, this Express backbone went on to limited production in 4 regions, and then this backbone was growing, and in 5 years' time, it became 10 times bigger than the original backbone. In 2019, all the traffic between our data centers switched to Express backbone, and later on in 2020, we started implementing access backbone segments that work with traffic between our points of presence and data centers. And of course, our objective in the near future to achieve this unified backbone state when all of our demands are moving around our backbone. We don't have a classic monolith. And this unified backbone becomes our only one. So this is it. Thank you very much for your attention. Thank you, Andrey. We have very little time left. Just let's take one question from the audience. So who'll be the one? Okay, the question is yours, but you're allowed to drink less coffee than you want. That's a good option because I don't drink coffee. So when there is an overload, do you use ECN? If you do, so no, we don't use it at this level. At this level, we don't use it. So short answer is no, and then we can continue our discussion offline. And we can quickly tackle some other question. Alexey Mitrolichev from Cisco. Thank you very much for your presentation. Please tell me what scale, what kind of order do you have? And you said that you limit segment depth and third. So sorry, and I cannot hear the last question. LSP redundancy. Do you reserve the band in the controller for the second LSP? Well, I'll try to go one by one. How many LSPs in one nexthop group? It's 16 LSPs. So one nexthop group is when we have the source region and destination region, and we need one nexthop group for one traffic class. Then we can just multiply 3 LSP meshes by the number of regions. We have a few dozens. You can multiply and you'll get the number of LSPs, so quite a lot of them. Second question, stack depth. We are limiting it to 3 to ensure the proper balancing. And the last question was about protection, right? Whether we reserve the band. Yeah. When controller works on these redundant LSPs, yeah, it saves a band. My name is Evgeny, and I want to ask Evgeny the following. Traffic metrics, how you create it, how do you ensure its integrity? Does it mean that there is whole traffic goes via LSPs and you push counter LSPs, and what happens if there is no control and you have traffic?
Excellent questions. So, collection of metrics, traffics. So, the collection through counter, nexthop group, yes, it's counter and LSP. Everything which is in LSP, it's increment counter, and this counter is collected by traffic matrix service, and that's how controller gets metrics of traffic. And there is secondary approach as well. Thank you, Andrey. And we have questions in chat. Could you please answer these questions in written form? Thank you, colleagues. Thank you very much. Our next presentation, the last presentation in this section, Arista Network, first system engineering Arista, with presentation 400G in DC interconnector. Andrey Nushtaev, we give a floor to you. Dear friends, good afternoon. My name is Andrey Nushtaev. So first of all, in case I won't be able to answer all questions after my presentation, you can see my email. Please, you can send me your questions and I will reply to you or even sent to our group of engineers. I think I have created too many slides. Please stop me when I run out of time. So the subject of presentation is tangible. But it's important to say we discuss things which is on the bottom of the stack of network protocol, which is closer to hardware. So, in other words, we'll speak about 400G and why it's important to discuss it. If, for example, you're a company not the scale of Yandex or Google, so sometimes people, when we meet, speak and they say 400G, it's some kind of space. No, it's not for us. It's not about us. And I would like to change your opinion, to stop this myth, and the technologies are so very close now to real world, to real people. So it's time to apply these technologies. So what is happening? These techniques and technologies, devices are available. They're available for a long time. I work in Arrest, and that's why I mentioned chips in Arrest, but there are other chips in the world, and they're available more than 2 years in the market. So Tomahawk 3, Jericho 2, and they have announced quite time ago, and the other new generation products will be available of chips, Trade 4, Tomahawk 4, I think majority of you knows, and this fleet of transceivers 400G, it's quite wide, and it can cover many tasks. Let's say for the mass usage. So it might be more interesting transceiver which can be recorded in 100, top 100. And it will be very soon new format of hundreds, and it will be commutators to support with these transceivers. And this is the story to compete these two standards, and it's connected with SMP, but there are nuances. So for optics from data center, it's substituted gradually from under-mode optics, and the cost of optics and transceiver, it's getting closer, and in the future it will be closer and closer. The next trend I would like to mention, it's not related to the presentation, but I think we need to remember this because mass media started to write about these things, which is far from the networking problematic. This is apocalypse. So this story with COVID, its impact industry, logistics, economy, and many, I think, faced already the price raising and delivery terms increased. So, and to cut long story short, we need to start with the basic. So transceiver, so everyone consider it plug-and-play device. So the coast is close to commutators. So on the left, it's electrical part, which is connected to chip. It's SerDes. And this is the main thing, why we consider it. And on the right side, it's optical or electrical interface. So inside, there are different components which transmitted signal in optical, detect signal, and so low-level things like strengthening, press strengthening, and etc. Transceivers has component EEPROM, which is according to the industrial standards. And so it can be tuned, or probably it can't be tuned. It's inside of EEPROM. So, and it's soft, which is in microcontroller. So what we are about this electrical part, which is connected to chips. How it's connected? This SerDes, they are directly or not directly connected to the same parts of SerDes in the chipset. For example, Tomahawk 2. So it has 2056 SerDes with 25 gig. And the modern chip can realize quite low-level functions from Ethernet, a MAC, Fire, some 5. So all those coding is on the chip. And transceivers through different paths on connected on chips. So, and the physical speed in commutator hasn't been increased. So, but we use different coding, and for every code we transmitted more information. Why it's important? It's important in context when it can complicate schema technique inside commutator and transceivers, and everything will be more complicated. And I know so that it could be some problem with optical fabric. So how we get new generations, change the scheme of coding. The amount of SerDes was not changed, but the speed was changed and it became more productive. So the latest Tomahawk 4, everyone is waiting to release these products. So for example, Tomahawk 4, so it was increased the amount of SerDes, so it became more productive. And another option, the amount of SerDes the same, but the speed of SerDes was increased up to coding PALM4 on 400G. So productivity the same, but the capacity is different. Transceivers. So everyone knows, everyone understands it's SAP, QSAP. And here it's important, this electrical part, how it works. So inside of chip, there is no high speed because it's difficult to speed up. And the speed is due to the amount of SerDes which comes inside of transceiver. It's been increased. So like 4 SerDes on 25, 4 gigs is 8 on 50. And because every chip, it's been rated on maximum productivity. That's how market demands. For example, 400 gigs are rated for the high-speed interfaces. But reality is that sometimes it's needed low-speed interfaces to connect or old generations. And for this, gearbox can be useful. Gearbox is primitive scheme, so about transmission of speed between SerDes. 25 gigs, for example, or additional functions, for example, retying and etc. So that's why transmission of speed and amount of SerDes. And it's needed at a new chip Jericho 2. So we need utilize chips in maximum, and we can't directly to connect in the old transceiver into the old chip. as we want to get maximum money, then we install Gearbox, which make this transfiguration. So for Sirdex on 25 gigs, and it's included two interface 100G. So, and from 4, Gearbox make 8. And Gearbox, it's not like a silver bullet. It's not commutated. It's not. It can do miracles. If we want low-speed interfaces to connect, like for multiple 25, so then we face further restrictions. And chips, Sirdex, it's transport, PHY, MAC, all those components which are responsible for protocol Ethernet. And this component can be diluted between different Sirdex, different physical interfaces, different tens, hundreds. So in this scheme, we have 4 Sirdex, and we need one-to-one in mapping. So it can be one instance PHY MAC between different physical interfaces, then 25 gigs. That's why Gearbox in this context, it's switching between lines and nothing more. And in fact, yes, we support, we have flexibility, we have legacy of interface on our new platform. And at the same time, we can lose capacity. So in our case, this 4 Sirdex on 50 will be transmitted in regime 10. 4 on 10, 4 on 50. So how it was done on legacy commutator? So this is mass product currently, 100 gigabyte chip. So we select one Sirdex interface, 10 gigs, 25 gigs. So and we select the amount Sirdex which is necessary. So it's very effective optics in terms of price, and it's also Gearbox use. So optics, Farelax, duplex, one modular. So it's only one optical lambda. If you remember classical 100 several signals, but here one signal, 100. There is one laser, one receiver. So why this optics is good? So there are less components because it's optical receiver. The source is one, but theoretically we can expect that these transceivers will be more reliable because the amount of components decreased. And this optics is significantly cheaper to compare with the same optics 100 gigabytes, which we get used to. So as far as for the chips, which is for 400G, everything is more interesting and everything is more complicated because it's electricity interface with different speeds. Let's say it's 40 gigabytes. We can work well with this. But as far as we do low-speed optics like say 10, 25, because of the fact that we need to decrease the speed of Sirdex, we lose capacities because we decrease speed of Sirdex and sometimes port capacity in order to use legacy optics. So this you need to remember. So with 100 gigabyte port insert SR4, we can get 4 turns. Then this pairing model will be switched off. So this you need to remember because it can complicate the situation. So some realization can simply collide. There are some tricky commands which helps to look what happens if this port, in this port will be inserted the certain transceiver and this certain speed will be selected. The system will alert you, but ideal realization will be that some ports have to be disconnected, and this you need to remember. Example of commutator on the base of Tele2. How it was realized, we have a single chip device, and on top there are several gearbox. Gearbox receive a certain amount of 50 gig, and then gearbox distributed to the holes in transceivers, and depending on what regime we select, so then ports change. Ports can be switched on, switched off, and they can be grouped. Optics. So this restricted optics is about this slide. Of course, it's clear we have different standards, and of course, it will be like this, but at the moment there is only one option, and it's not the best convenient option in order to break out it, because as far as the legacy optics, it's possible only 200G or 2 by 200G. It's not really convenient, 16 fabrics, but I have to accept it's the cheapest one. It's difficult to compete here. As far as for the one modular optics, everything is much better, and what is important to pay attention to, in the center you can see this optics, which is EDR XDR PDAL4. It helps. On one modular fabric gets from 500 up to 10 kilometers to compare with trivial ones. And the most interesting, which is already existing, and starting this year also, this is very interesting solution based on the SN connectors, which allows to make breakouts without breakouts. What breakouts?
So you have one 14 transceiver and you buy the so-called Hydra. No one likes that normally, but you have to use it because there are no other options. As for this option, this is the SN connector. It'll be available quite soon, and in the transceiver itself here, SFP or XD4, it has 4 mini connectors that are called SN connectors. Here you see an example of what it looks like. I don't know whether you can see it. So there are 2 independent fibers, and these transceivers allow to break out 400 gigs in a very convenient way. The algorithm of how to choose a transceiver, well, I won't go through it, but you see the key points here. In which conditions do you have here? Well, if you plan for the future, then you need to take into account the new optics, because you'll make use of it in the future. And why do you need this at all? Because everyone wants to create a network as cheap, in the cheapest manner. But why do you move on to the new technology? to pay less for every bit of information, and everyone see that because gigabit becomes cheaper and cheaper. So as for electricity, it also becomes cheaper. Well, not in Russia, probably. And it leaves the open doors for quite a simple migration to 400G in the future, and it's unavoidable. And important thing is that the cost of the new fiber optics for single mode is lower compared to the legacy. So if we talk about 100 gigs, but if we have multi-mode, then it's comparable. Well, there are some nuances. When we have SR4, it's hard to compete against it, but you still can get close to it if you take into account all the costs of infrastructure and so on. And then example of the design. Well, naturally we can show some customers' design, so that's why it'll be some draft design. You can have this kind of switch, and if you have 100 tracks or 100 couples of switches, you can install some primitive Tomahawk and break 400G out and get this kind of network. Some useful links. As for the hardware, there is very little information about hardware, and it's hard to get it unless you work in the vendor or you have friends there. But there is a good source in Russian language by Marat. Was a very good bedside read. So this is it. Thank you very much, dear colleagues. Thank you for the presentation. I'll just give you one comment. When we talk about MPO 400G, we have SR4.2, but it's quite expensive. Well, it will keep appearing in the future because next year we're expecting EBD, and as for SR4, when we use, well, it'll appear, but it'll happen next year, and we have to look and clear that it'll be the cheapest option, but there are limitations in terms of the distance, 100 meters tops. Questions? Hi, my name is Fodor. Thank you for the presentation. It was very interesting. I have the following question. The gearbox, is it a point of failure for groups of interfaces? Well, I've never heard of it, but it's a primitive device. Probably something else will fail. Well, if transceiver will die, then you won't know about it. It can be in transceiver, but not necessarily. Normally, it's inside the switch. I had this experience, but we would just replace the card. That's it. So, do we have to distribute links to avoid links going to the same gearbox? Well, there's very hard connection. Gearbox is a small device that has 8 inputs and 16 outlets. Remember this yellow square, the picture with the photo with the yellow square. So, yeah. And if you talk about reliability, if you want to, well, if you take Tomahawk and you connect to different cores, then you get to into different gearboxes, but you don't have to think about it. Well, I think if you use scale-out design, it's easier to use scale-outs and install several boxes. Yeah, absolutely. Hi, thank you for your presentation. I have 2 questions. First question: will there be Arista balancer soon? And second question: soon we'll reach the physics limitations and we'll have issues with electrical part on the on the card. When will we have photons and optics inside? Well, it's hard to. The first question we discussed in lobby. The second question, well, I don't develop on optics. And from what our developers say, 100 gigabits SerDes they'll stay for a long time. And then we'll have physics limiting us. So we'll stay there for a long time, and then we'll see. Thank you. Oh, good. You can hear me now. Hi. I'm Alexander. I'm also from LinkMeUp. You had many SFPs on your slide, and it really crushes your brain. There are so many that you can't figure it out without a bottle or something strong when we are talking about optics. Unfortunately, you cannot have a walk around here. And in the beginning, I said that on the one hand side, we have this battle between KSP and SPD, and this battle is not over. And just now, I was reading about those DSFP and DD, and these are two different standards that tackle the same task: how to get to the next level, 50, 100 gigs, and so on. But they're different. What will happen with this next? I don't know. DSFP are saying that we are optimized for 5G, but no one can tell what's this optimization. From my point of view, what you can do is that you have a cheaper optics option, or maybe you can try to switch to single mode if it's easier for you. Between leaf spine and super spine have the same amount of zips. PSM duplex or PSM4? SM4 or PSM duplex? SM4. Oh, PSM4, yeah, okay. Parallel optics, 10 gigs. Well, I don't see parallel optics option here. Yeah, we need the network people, see? Thank you for the presentation. Do we have any prospect? You know, like when the revolution happened, is it possible, are there any prospects of seeing a simpler solution? Well, I'm not talking about 400. Having 100 gigabits with the help of using single fiber without any complex boxes with DPDK inscribed on them. For it to have inside the transceiver, inside the chip, you mean long distance? Well, like 16 decibels, to hit 16 decibels limit. Well, the TAR4 will appear. It's not WDM, but in this sense, it'll be plug and play. You just stick it in as a regular transceiver. It's 8.5 kilometers. When? This year. Yeah, ZTR 100G, they're available. No, two. Yeah, I need. So what's the question? I'm not talking about 2 fibers. I'm talking about 1 fiber. So the question is, when we'll have 100G entered through, delivered through a single fiber? The frequency is not important. You mean 1 fiber, 2 fibers? Well, it doesn't matter. It's it's not about the frequency, it's about when will we have 100G in a single frequency.
So one opticals, this is reality. So optical, which already meant, this is one signal and fixing or waves lengths, and it's distributed on different optics, but it can't be inside one double DIN. Let's move our discussion to whole. I saw one message from Vasily Komersanov. Could you give a microphone to him? So one last question and we go to break. So I'm just in these things. If you want to use one opticals, you can use circulated 2i transceiver. You can use for one optical. So and there are 400G. So, but I can discuss it with you during the break. Thank you very much for presentation. Now we have a break. We come back in 20 minutes. So we wait for you here.
Это будет совместный доклад. Представляю вам Антона Корtunова. Это технический лидер команды Nogiev в Яндексе.
Anton Kortunov, technical leader, Yandex, and Alexander Petrovsky, leading system architect at MEM company. So, Lena, what's your opinion? We follow multi-vendor network. We want to automate everything. Of course, we have some difficulties. That different vendors on different platforms. So we constantly need to finish our automation. That's why we look for operational systems for white box. And now this is at the stage of research. And I think this year we start testing of operational ones. Great, Anton, we're gonna floor to you. Thank you very much. I know that some of you already have seen my report on DevCon, which I already presented in the summer, but it was for developers and Dev. It was for the developers who works with switches. And now I would like to speak about such things like operation, exploitation, engineers. A lot of was said today that we need to automate engineers work, CTP, analytics, controllers, but etc. But we have engineers now and developers can work together. This is rating softs. So like fixing bugs, improvements, updates which can make it better. And SwitchDev, this is collaboration between developers and exploitation of network in the company. So this start, this is the basic things to be very short, close, torus, spine first level, spine second level, IPv6 on-3, BGP everywhere between all our devices. So boxes we try to do not very smart, topology is regular. So the same Facebook, which you already heard today, they do the same topology, approximately the same. And all the things should be scaled out, should work in data center. About 100,000 servers have been installed in data center. What do we want from the box to grant switch? We want BGP to work on IPv6 link local addresses. So that's for our design network. We want that COS, SAL, counters works. We want monitoring and telemetry. We want to research negative scenarios which might happen in the network. And of course, we want to be able automation of deploying our switches. So white box sphere, this is Cumulus. So this is Linux, which works on switch. A lot of things should be installed there, and in the production switches Mellanox on Cumulus. And we installed there our additional agents. We installed there our telegraphs. We installed there our own scripts on P counters, which helps us to tune display. And we tried Sonic, but it failed even in lab testing. For example, IPv6 and clock addresses didn't work on interfaces. And 1 year ago, we started testing SwitchDev as a solution. And in April this 2021, we delivered this first delivery of switch switches. First of all, thank you very much, Alexander, because he helped so much to us, support, I would say, of the highest level, third level in DRM chatter during the day when it's necessary. It's so great. So we haven't seen this support from any other vendors. And it's based on Multi, antibiotic 1804, probably not the most fresh, but this is on our servers. In terms of system of launching of all scripts, we use systemd. We use scripts to manage scripts, Mellanox chassis, electricity controls on heat sensors, heat sensor electricity. So all this machinery is ready. It's distributed Mellanox and it works very well. As for the interface management, we selected IFAB-down2 from Cumulus. VRF works very well here. And subsystem VRF original arrived from Kumus, as far as I know, and Alexander patched it a little bit. So as far as for the image which we loaded on Switch, everything I said, all the initial things, is on our VT from the submodules, and we use GitLab in order from the set of these initials, originals, to select image. We have different packages, Debian packages. Part of them our own, somewhere we did patches. In Linux. So thank you, Mellanox. It's upstream with different parts of patches. So when 1 year ago we used 5.9, it was about 3 or 10 patches, and we updated 5.14 to work it successfully. So we collect Debian packages from all of it and load in our local repository inside of Yandex, the same which we use for work of all our servers. And we use our ready machinery. And in order to develop versions of this image, we use these mega packages. I don't know how many of administrators of Linux familiar with Debian packages, but it's very simple story. We create Debian package which has nothing, and we establish connections which are very different. For example, when we install of a certain version, it will attract the versions of packages which are necessary. So we need tough connections of our version, which is version of mega packages and version of softs which we have inside. So when it's updated somewhere in stream, so we take it in our change log, update our version, and new version is ready. And these packages can be updated in the switch in itself without relief of images. After we have done meta package and loaded in our repository, we create our image which will work in our switch. It's very simple operation. Also, we make root and we take Ubuntu Bionic. We install our meta package. We input several our scripts there. We attract our users. We distribute keys. And after with the use of ONI installer, we build our ONI image. So it helps to personalize image on switch in itself. So in order to make it work, we make a serial number of the switch and write it in the inside. And after this, it's not some kind of anonymous switch. So this is certain switch with serial number, and then later we will know what we have to do with the switches in case of necessity. So after we loading this in West3, then we can deploy it in switchers. SwitchDev deployment automation. How it happens? Only it's some kind of loader. We can say it's quite rich and have DSP. As soon as it gets IP address, it have special image, and then it install it. Everything quite simple. What are our difficulties? Data center IPv6 only, out of bank management network with it's not IPv6 only. So, and we would like to move to IPv6 only, but in onion stage it needs to be developed. And in the DC request, we don't have serial number. We need to provide an address, but we don't know whether we will load it or not. So it's not convenient part. So with the help of Onion, we made a request, and then we wanted to tune our switch. And for this, we need to use ZTP. ZTP, I think we saw in previous presentation, but it was ZTP data server realization. But ZTP realization in client, I haven't found. It is in Cloud-In, but they are all in launch of image and deployment in clouds. But ZTP client, we don't need it. That's why we have created our own one. And based on DH client, launch script, take script which we need to perform, and then we need to think several important things. First, how to transfer logs from this unnamed switch somewhere in order to know what is going on with this one. And in all ZTP in leafing switches, I think it's the most difficult process. So it's not like we switch on switch and wait for 4 hours. No, it's not the best solution. So, and particularly in our case, it was some kind of inconsistency how we worked with our netbox switchers and vendor switchers. We have consolators, console-based, and so engineer makes some kind of commands, the base configuration, then update soft. So in case of using Mellanox and ZPT, there are some nuances, which is related if the old one comes when switch has menu, grabs at this moment of loading, then it leaves, press the button, and it stops. But this is not the best part. You have to be very careful and pay attention. After we make configuration to ZTP installed it, we need to think how we'll live with these switchers in the future. Majority of you, this is switch engineers, and of course you have selected the second way, white box lay, black box way, and you know, because you get used to this configuration templates, rendering, commit, feedback, you come, commit, make configuration, something change, you need to send it back, and this is, we selected too, and we want our white box device looks like our network boxes. So in spite of its Linux, but this part we don't particularly like in terms of operating. But you can select another way. If you have freshly built cluster, especially if its cluster is not big and narrow usage for the certain reasons to operate, then you can follow the other way. If it's server of Linux routers with several types of interfaces, everything which can be used for service, the same can be used for switchers, it will work well. But of course, you need to start from what type of systems of configuration is being used at the moment on your place. So, and we have created Linux commit API based on etc keeper, and it's based on GIT, the storage backend, and there is special mechanic which, due to configuration, understands which service reload. And in order to make our switch look like Juniper, Arista, whatever vendor you want, we make authentication authorization through TAC Plus for authentication, patched sudo. And if we look how ISIC is being programmed in this switch, here we can see big difference between Cumulus and SwitchDev. In case of SwitchDev, we use nuclear realization of all primitives, and it's done offload of nuclear functions in chip. So it means we use all these powerful subsystems of Linux. They are not DevLink, not Link, and TC. So, and through DevLink, we manage how we split ports and reswitch them back. We can tune triggers and policies. We can look type of resources being used through DevLink. But here, the other hand of story, DevLink, it's quite complicated structure with quite complicated messages, which is not really detailed in good manuals. In order to understand what is going on, you need threads, you need reading code, and then you can do something good. So that's why we really didn't want to do this. That's why we DevLink used as a utility. And we can do patent code for you, those who use DevLink. If you want split code on 4, then it's easy to write code which is code is not unsplitted. If you want unsplitted in 4, but you would in 2, but you would like in 4, you need to come back to 1 and then again split up. So it's not really convenient. That's why we didn't write it.
That's why if you try to configure split from 2 to 4, then you'll get an error. But if switch works, then everything will be okay. TC is needed to manage the queues and quotes and counters. A very necessary thing, but a very complex. To set up the basic course, you'll have to read, well, I don't know how many lines. Well, you need to spend 15 minutes reading a wiki page and then reread it if you haven't used GC before. And if you haven't used Linux really by a network engineer. then you need 1 or maybe 2 days to figure this monster out. And it's very important to avoid creating some monster while you're doing it. And you'll have to rewrite WLAN, and there will be complex chains like to save the resources. So it's a very complex thing, but it's very powerful. Not nice to use. So what do you want to see in the future? So what I told you about is something that we have in production, and we are happy about it. But we would like to have more, better closeness to what we have, to what vendors have. You becoming more uniform with vendor boxes and hiding all those dev links to see IP into a big config, and make it compact, make it into a single file. There will be fewer issues with committing it and so on. It's easier to automate it, to use the tools. You just run it and that's it. And it will be similar to other vendors. And there is another thing. SwitchDev gives a lot of opportunities to manage the chip itself. And it's best when you don't work on it in the fabric, but run the tests in laboratories. And here we have an idea that maybe will help us to create even more complex configurations, but it's, the bright future we are just thinking about. And in presentation on firewall, we had that idea, and in other presentations. So being a programmer, not a network engineer, I think it's interesting. I think it's promising to be able to use the IC opportunities without getting stuck. So that's our vision. That's my vision, and Sasha will tell us about what the point of view of NVIDIA and Melchior is. Thank you very much. Hi, everyone. My name is Alexander Petrovsky. I'm system engineer from NVIDIA. And I want to give you an update, SwitchDev driver, to give you an update. Overall, SwitchDev driver is called MLXSW. It's a development in the core. It's been available since 2016, fully supported, and we are developing it together with Linux community. We have an engineer team that creates this driver, but we also have a lot of support from community. Also, based on this driver, we have a solution that we call Linux Switch. It's not a product; it's more of an initiative that allows to install any Open Linux in our switches to make sure that it's run as a network, as an NOS. And as for speeds and feeds, you can see them on the screen. As for functionality, basically it supports all the functionality that's necessary for up-to-date data centers. Bridging, routing, and other things like multi-tenancy, VXLAN, EVPN, VRFs, well, basically anything you needed. And all that can be managed with an open source protocol stack like Quagga, Bird, FRR, and you can take any and use any distribution like Fedora or Ubuntu, and you'll get a working box with an open source solved. And it gives you complete you fully control the code and you can customize it the way you like. And naturally, it makes you very flexible in terms of creating solutions to fix what you need to get your tasks accomplished. If we talk more about how SwitchDev works, we are not only working on the driver, but we work on the core ecosystem. And use the same things are used in any kind of open source systems, like checking the dropped packets. Anything force flow, it's been implemented too. Resource monitoring, it's very native. Then managing transceivers, managing transceiver parameters and other things that were not there in Linux, but now they're there. Everything to do with networks. And speaking of ecosystem developing on the basis of SwitchDev, even now we have a number of cases that really work, starting from data center and ending with embedded solutions using different ASICs. Marvell, Broadcom, all kind of companies and many other vendors, they support SwitchDev all the time, developing the open source environment. So for those who want to start, how do you do that? Well, first you need to read the documentation, how to set up, how you implement. It's published in OpenWiki. You can take a look at how it works. Step number 2, you can get your SwitchDev switch for testing. And the last step is to download or to put together your distribution, and you can start using it as out of the box. We have Fedora-based, Ubuntu-based image, and there is a Dent. It's a NOS that fits this product. I guess this is it. Thank you very much. Yeah, we do have questions. First question from the chat. I think it's a question to Anton. Why SwitchDev? Do you plan to receive support from other vendors, or it's Mellanox Networks? Well, I told briefly why we don't have much choice of what you can do on the switch. Well, we have Sonic that didn't work with us. Camus is not really open source. Why didn't Sonic's work? It's about the addresses. Yeah, let me give comments. Sonic architecture. Sonic is like a noodle factory. Everything. It's from user space to kernel space and so on. It's hard. It's hard to debug. And it was very painful to look at it being a developer, like really bloody tears. Anyhow, it didn't work for us. We have switchboard and BIOS. I'm trying to install them install this for 2 months, and it's not working. That's why I switched it. As for Marvel, they give the promises, but nothing's happening. Nothing's happening. Well, if SwitchDev is supported only by one vendor, then you're dependent on one vendor. But we still have other devices. Why do we want to have SwitchDev compatible or similar with other devices? Well, that's the reason. So you don't have information on whether other chip manufacturers, whether they'll be supporting SwitchDev. No, I don't have the information. If we talk about campus switches, Marvel is really supporting the development of the driver, and another big company like Amazon, they use Marvel switches with SwitchDev. Thank you. Do we have questions in the audience? Good afternoon. My name is Igor. I'm asking about using this in real life. It's very nice, and we can customize many things, but unfortunately, we need people for that. We need people to support it. You need to find them in the market. It's not just programmers, right? Initially, a person who's working on networks may not be good at it. Yeah, that's true. Well, actually, in terms of development and preparing the distribution, it's more like it's similar to a usual server. As for testing, yeah, indeed, you need special knowledge. And here, I've mentioned it's at the very beginning that you need the developers team has to collaborate with network engineers. And who'll be in charge? What do you mean? So, who will be responsible for ensuring collaboration? Well, I guess they have it in Yandex. Yeah, it's very doable in Yandex. But as for the usual people, yeah, we can talk about ourselves, but there are quite a few companies. Well, I'd say there are companies in Russia which are able to implement that, and you can start from Mellanox and on the basic image and basic scripts from which you can put together something that works quite well and you can use it. Yeah, you have to think about how it'll be fit into your automation system, but if you use Kumus, then you'll need this as well. Basically, it's working. And I'll advertise Sasha Zubkov and people from Creator Labs who also use SwitchDev. If you are interested in more cases, SwitchDev cases, then you can come approach us offline. Thank you for your presentation. So, will there be a module developed that works with GNMI in Yandex or in Marvel somewhere? If we talk about us in Mellanox, our SwitchDev is about the driver, and we ensure all the Linux infrastructure on it. As for user space, normally we don't touch it. That's why it'll be done by Yandex. Do you have it in your plans? We don't have any specific timing for it, and it's not written down, but it looks very promising, including the transition from some legacy devices, migrating from there to that. Other vendors, do they support GNMI? Some do. We have a question from the chat. Yeah, but unfortunately we don't have time. Yeah, unfortunately. Yeah, we'll reply to it in the chat. Okay, thank you. And then we have the next presentation. We have the next presentation that will disclose some secrets of network automation. We have Inozemtsev from Cisco. Dear colleagues, thank you very much for staying here until the very evening. And today I'll be giving some, I guess, basic introduction to Yang and how you can use it in our automation. But before we start talking about Yang itself and data models, let's spend a couple of seconds on modeling. People who have business analysts or architects in their books, amongst them, there is a popular joke, a quote from Borges's book, where he's saying that there are different creatures who belong to the emperor, which are painted on the thinnest of wool, and so on. And this is a crazy classification that Borges provides, but it can be very similar to an information model. Basically, it's any description of reality. And we can hardly use this kind of description, but overall in the industry we have two quite formal standards. First one is UML, and if you ever worked as business analyst, then you understand it. It's the language that has to describe all the possible entities, and you create design based on that, and then you provide class diagrams, sequence diagrams, and you give all that to the developers, and they write the code. So there is like distributing the work between BAs and developers. But generating code straight through from UML diagrams, all these attempts failed. And the second formal modeling language is BPMN, and you can see it at the bottom of the screen. It describes business processes, and it's better because there are a lot of tools which you can use to describe the business processes, and you can say that if this workflow is run, then you'll get something. But such abstract information models, they don't really help us when we talk about how to work with hardware. If we need to work with the devices, we need a byte-to-byte fit, and subsets of information models which describe the interfaces and working with devices. You can call them data models. Yang is one of the languages for data modeling, and there is a whole story how it appeared, and the story was told by Martin in his interview, so you can check out this link if you have time. So briefly, the story is like that. When time came to manage the network in a centralized manner, then it was clear that the languages differed from vendor to vendor, and there are different approaches to it too. But there is a mismatch with what you have on equipment. And basically, when Yang was invented and when developing models, they were trying to describe API from two sides, from the system point of view and from the device point of view. This language turned out quite universal, but it's at the same time very formal, and we can be very discrete. We can describe the attributes in a very discrete manner. For instance, specifying VLANs. It's very easy to learn, but at the same time, machines read it quite well, so we can generate certain code out of it, and we'll talk about that a bit later. If you never worked with Yang, it is structured by modules. Basically, these are the files that describe a certain part of interface. Inside, you have certain groups on the structure basis, like containers, I'd say, and there are attributes that are called leaves. And the structure of information exchange is not static in Yang. You don't just say that we have a data set and it should look like this, but you can reuse the code inside a model. You can group. For instance, like in this, you can see here in the slide, there is a group for description, and then you don't rewrite everything from scratch. You just leave a reference to this group, and with the help of certain key, you modify it. It can be similar to inheritance, but it's not strictly speaking an inheritance. And the model should be changing dynamically, and when a part of data depends on the other part of data, you can use the references using the keys. You can say that the lower part of the module is valid if this, and if we have another condition, then another part of the model is valid. So basically, we looked at what data modeling is, and let's try to figure out how we can apply it in practice, in real life. But to do that, we won't be studying specific cases because there are a lot of them. Let's try to design some random system that can be applicable in case of many scenarios. If you're just starting, then you will probably find yourself in such a situation. There are some libraries available. You can use them. You can get some data. You can get the data from, you can parse the data coming from the devices. And when you have few cases, you can do that, and you won't need YANG. Well, you can, it'll be something absolutely not necessary, but the number of cases grows, and little by little, you will prefer a certain framework, and we have a very good community that works on the network automation in Russia, and you'll be able to find a lot of links telling you what to start from and so on. So you'll start working on that, and you'll be getting your own libraries. You'll create your own favorite parser. You'll find a way of configuring the device, and you'll create your own library, and you'll have some object IP to not go through the whole configuration. And you'll be rendering the templates, and you'll be good at it if you have a more complex configuration. So now you have the different configurations, and so you have several configurations. They're different, and it's okay. But at a certain point of time, what do you have? What do you accumulate? You won't be able to fit into your regular thing. Then you need to create some driver or adapter, sending everything there, and have the business logic separately. Well, templates, okay, I'll be sending them to the driver. Driver will be sending it on. And in this case, YANG model of CLI device, not necessarily enclave. It will be the most logical way to describe the contract between your own libraries and your use cases and this driver. Basically, for every scenario, there will be two internal flows, business logic and expanding the driver. And yeah, you can live with that. But when you go to production, you'll have the following question.
So that's quite very good. I like it. And in my practice, I had similar case when we realized TCP, and we faced, unfortunately, in regime when we need to ensure this to provide storage. We face these difficulties, and in order not to start everything from the beginning, not to break network, and if we start to implement database intermediate ones, so then here it's quite difficult to stop, not to start to add something new entities, new structures. For example, it's not a secret that big amount of equipment is being supported by synchronization of configurations, and we know that in base the configs it's already has gotten, and as it's and certain infrastructures, we understand this is the same version. There is no need to always to get it for every scenario because it's time-consuming, cost-consuming. So, and we implement definition base. So, and we have some base, but we don't create from the beginning different languages. So what we can do, we can use Yang model and to create scheme from this Yang model, but technically it's already it exists solution, many products on open source products, but it's not really convenient to work with base directly. We will not be forbidden to work with the selected. We have device models, we can generate them in base, and it's very important here because we have the only one model, the only one file Yang, which describes 3 times simultaneously API, scheme of base, and structure with driver parsing configuration. And at the same time, we understand they are multi-vendors networks, and we need to realize scenario on top on several vendors. So, and let's say an example, provision base 3VPN. And of course, we can create 3 different cases, but it will be hard to make migration from one equipment to another, and we create such type of hierarchy. So, and we add service code, and this service code is unified and vendor independent. And for this service code, to store its data, we use Yang and implement definition of service model, service modeling. So this is industrial entity. We haven't come up with this when I started about this. Last week I had presentation. It was committed 644 standard service models. The most active ITF, but among those 644, not all of them final ones. There are many drafts there, but we understand 644 service models describing services, protocol of routing, VLAN encapsulations in interfaces, etc. So what we can improve more in our hypothetical platform for automation? First of all, we believed that our samples can be rendered and transmitted in driver in terms of ready text, and we can enter in configuration regime, read drive, and send to the device. And reading was done through base, so this is some kind of thematic. In order to avoid the symmetric, we have to create 2 simple steps. First step, so that base, it's not the easiest one, and we understand it's either triggers or storage. So when in base, we curse some kind of procedure which can perform a code. If we put a code to the driver which need to change attributes, then driver can follow this way and change something in configuration, either commit something or save. Or IM, we have object PI to the base in order to change something, but to write this code on every attribute, it's not convenient because before it was samples, and to understand there is scenario and there is sample. And in order to back this convenience to work with the samples is something integral, we need additional translator, which has variables, looks the samples for scenario, render it, and then send it to ORM. This pass-through translator can be considered as high-level API. The direct challenge. And we have very cool architecture. So the main advantage is so the insurance of transactionality, but in practice, due to our ordinary tool, stateless tool, which we use to work with configuration in our network, it's difficult to support. But if we have an intermediate base and we make configuration written in base, so it's much simpler and cheaper. So we can make atomicity changes, young scheme, consistency, isolation, longevity. So also we can make isolation on different equipment. We have base, which describes configuration of all network. And if we address to it through certain API, then transactionally we can change network. In order to earth and discuss how it's used now, as far as for parsing data, in order to make driver, I would recommend you go to Yandex.Cloud.Network project. As far as for the magic which is related to data stores, database, schemes on Yang, it is realized very well. And good example, MDSAL, Opal Delight Controller. This is some kind of intermediator. And the next projects on Topper, TailF, and Clixon, they more oriented to work with equipment in itself, like SwitchDev, libraries which are installed on equipment and provide centralized PI to the processes. But also they can be used to provide data store and processes they perform. If you want to make experiments, so there is a link for you. You can try to test. You can try to look several projects, Open the Light, where ordinary KV data store was used. It was already parsing with drivers. So go through the tutorial and look how it was done. And there are other amount of projects were done by different vendor projects. So as far as for the architect, I would like to add several stages. So all those libraries, which I mentioned at my previous slides, so they provide also automatic render on CLI. And service code with the same model, we can realize API for your different automotive system and CLI. So, and all other things we can keep the same. And if you already work with the structural information, and if you work with this information in database, you can make links between service code and code between devices, which is described by Young model. So it's how we're about to get delta between different challenges between services. So that's a very simple way, because we have configurations which we send through driver. We can find this delta. Better way, because we have very clear mapping between services we activated and configuration we send, and dependencies between different services. And also, if we use Young, if we use the main programming language to work with configuration in Young, when it's space for your work, automatically you get the access control, which is inherited from simulated line, from netconfirm. There is special mechanism. NACA might have specific RFC, and describes model to configuration access policies, ways of configurations, and users. Initially, of course, when we look at it, it's more for configuration plane, but recently we developed a separate direction which helps us additionally to running configuration, startup configuration. It helps to have additional data stores which are intended configuration which we wanted to apply, and operational. So what is already working and gives us interesting scenarios when we can watch how configurational groups impact on elements. For example, we have BGP peer. We put it into group and we want to understand what configuration they need explicitly, or it was inherited from the configurational group. So, and couple of moments. Young can describe everything is already mentioned, and one of the key characteristics of Young that it can be extended, and you can do it by your own in terms of plugin to the environment you select for platform development. For drivers, there is CLI annotation, CLI, and one structure will not be enough. So just to write simple no description and no description what happened, why. So, or for example, to make transformations and regap like it in Young, we can describe extensions which describes not only configuration of service but consequences of stages of service, like declarative workflow or complicated scenarios when we generate it, on what devices, what activate, and then on every device we make configuration in itself. And if it's interesting for you, so I recommend you. So the conference, Viktor and Stefan conference, this is recording of this conference, is how Young was used for device models, for the service modeling, and also recommend you my favorite book, which impacted on standard people, Joe Young and Benoit. So when it's about Young in terms of syntaxes of language on simple examples. So that's Young can be like universal language for modeling of services for network and complicated configurations. So that's all for now for my presentation. I'm ready to answer for questions. Thank you, Ivan. Good afternoon. My name is Evgeny. So, consensus and industry. Young like description of data model between devices and management systems or any other systems. So standard recommendation ETF in order not to produce other boxes which can't be modeling on Yank. So what do you think of services Yank on Yank or DOSC? I think DOSC it's not quite applicable in terms of service configuration for the network. This standard is most about deployment for IT application, and it helps us to describe connections of modules, and it can be used for some base services of connectivity, but it's not suitable for, let's say, random walk of equipment configuration. To write on DOSC service which must tune NNI, honestly, I can't even imagine this, and I don't know how to start to do this. Init info tags. So Yank and Stack protocol, which is related to this, how adequate it's to these scenarios when we have 10,000 of devices. For example, SIP telephony, when I have apparatus telephone, someone is switched on, someone switched off, different versions. How adequate this approach? As far as for the versions, you have to remember when we work with versions and support different types of versions, in certain drive it works well, and at minimum 4 different ways in terms of amount of device and scaling. As far as scaling, tens and 100,000 of devices, Yank it's industrially well standard to work. I personally know when it's 10,000 of devices. It's in practice. I personally know this 100,000 of devices. I personally know it was like for CPE work. It was KIT proved CPE. Ilion I don't know because I didn't follow the project full. Good afternoon. My name is Igor. Very interesting, a lot of information in this short time, and I would like to clarify for transactional approach. So modeling situation, there is transaction, it's not proved by the part of equipment network, and there is a threat for our database integrity. We don't know what happened. We don't know how programming our infrastructure, our software should react. So what is practice in this case? How to correct it manually? As far as for the practice, you need to consider 2 different scenarios. So the most frequent scenario is we make some kind of activation through driver, but model of driver so it's different. It's different with real reasons, real life. For example, one command is modified and commit are not able to go through, and driving is controlling this. And the typical approach, like real practice, is to start to invert those commands which you inserted. So it works like this. You follow the way when you're configuring something, you stopped, you failed something. So it's modeling, it's structured, and it's quite easy to make. And then again, it just consult everything and go back. And you can see it in synchronous way. The situation is more complicated when you lose access in the process of configuration. So you don't modeling the configuration is saved in base, but at least you need to store IPA addresses and device of synchronized and non-synchronized. But if you lose access, then it's in account of sync, and the next request don't go to this, but data in your base, this is data which were before transaction. And when you restore it, you need to make synchronization into the base, and the services can be fall down, which were synchronized, and then you need redeploy of those services in order to change back this configuration, but it works. This was ideal answer. You even answered me. I even haven't managed to ask the other question, but you already answered.
Все.
Any other questions? Oh, we have another one. Yeah. Ivan, thank you very much for your speech. In this model, what happens with reconciliation when the system, for instance, when the system drops and it starts trying to communicate with boxes? When you switch between active and standby, you don't lose anything except for the transaction that was being completed at the moment. Then we get back to the previous reply. Then we check the device configuration. If it's sync, then everything okay. If it's not in sync, then we redeploy the services for them to go back. If there was no transaction happening at the moment, but in reality it takes around a minute, depends on how it is. Basically, you switch to a different node and everything's running. Thank you for the presentation. And we swiftly move to the final presentation of our day. It will be about homing, and we are welcoming Alexander Petrovsky back. So the floor is yours. Welcome again, and in this final presentation I'd like to tell you about another interesting thing that is about the host side of the network. I'll talk about what kind of processes are happening during the recent years. And the idea being here that we are migrating towards host, how it's moving towards host and how it can be implemented with a better productivity and based on DPUs, new type of network adapters. So I'll start from afar. If you take a look at what a modern data center looks like, especially cloud DC, so we have servers connected to the hub of a fabric, and all kind of work. You may have all kinds of workloads in there. It can be VMs, it can be services with containers and so on, and bare metal, and they have to be isolated from each other. So it should be multi-tenancy, and at the same time there should be some overlay technology supplied to not depend on the physical topology. Normally, this overlay is implemented in switchers and the service. And if we talk about an interesting trend that we've been observing for the last 5 years, this trend is about transition from switching to routing on the host. So we are moving to pure L3 to routing host scheme when we place router on the host, and there can be a virtual switch. And host is working with Tor switches, and thus it becomes a part of a unified L3 factory, and this allows us to simplify things. It's been implemented in the form of software router in Linux, for instance. Another interesting trend that we've been monitoring, that we've been observing for 2-3 years, it's not about moving routing to host. It's also moving overlay services to host. It started from a solution that uses the controller when our virtual switches creating some certain overlay, but control plane is centralized and it's implemented on the external controller. And another solution is as controllers. When you have instead of a centralized controller, you have same data plane, you have a distributed control plane. Nowadays, EVPN protocol is used for that. That can ensure a similar functionality. This is all very well, and it's been implemented in many clouds, like in public clouds, Yandex.Cloud, but there is a problem. The first challenge here is performance. When we additionally load CPU on host, especially with some complex pipelines, overlays, or a virtual switch and routing, and we spend CPU cycles on that. And also, since CPUs are not designed to process the network traffic, and we get this kind of thing and at the bottom of the screen. It's quite a famous image that explains what network stack is like in Linux. And you can see that it's very flexible. It contains a lot of pipeline elements. But you have to pay with efficiency or productivity. And if you implement something in the kernel, you have around 500,000 packets, and it's very slow. You can speed it up with DPDK, for instance, but you spend processor cores, so even like that, you won't be able to fully utilize 25 gigs. There are two other challenges, which are isolation, which is extremely important. When you have a cloud and server doesn't belong to the cloud provider, or when there are manageability issues, like a network is managed separately and servers are managed separately. And manageability overall. In terms of manageability, it's quite tricky to organize. It's quite tricky to separate managing all this on host and managing the infrastructure. But during recent years, something happened in the world of network adapters. They have evolved. We had a usual NIC that was sending packets at a certain speed. Around 4 years ago, the so-called smart NICs appeared. These are the adapters which could take the whole data plane and the hardware level. But during recent years, a new generation of adapters appeared. DPU, data processing unit, and what's special about them? They can take all the infrastructure, network, storages, all the infrastructure that processes things. And with the help of these adapters, you can resolve the challenges that I've been mentioning, and you can ensure flexibility, processing packets on host, and you can good hardware efficiency. DPU. What's DPU? DPU is a system on a single chip that contains all the necessary blocks. It ensures data plane. There are certain data plane accelerators, flow-based accelerator, data path accelerator that can further process these packages, protocols, different emulations, additional load script accelerators, and there is a control plane part. Well, we use ARM. Of course, basically it's a fully-fledged CPU that can both manage data plane and it can process packets in specific ways. And of course, there is a whole set of special blocks like inbuilt precise switch, inbuilt cache, and DPU stands between the external connection, like uplink, and the server. So all the traffic goes through it. And the idea is to take the network stack, transferring it to, move it to DPU. If we talk about how we can do it, I'll start with the software architecture of DPU. Even if it's just an adapter, basically it's a mini server. And there is a standard loader, like UEFI. And on top of it, you install standard Linux, like Ubuntu. And there is a SAM driver package that you would be installing in regular card. And there are different safety and security things. And there can be also a BMC interface and naturally the firmware itself. So basically it's a server that's in front of your host and takes certain functions from it. So what's a DPU networking model? Some important terms. DPU is using SR-IOV functionality. So it's the next level on DPU. If we talk about SR-IOV, DPU sees the uplink as a separate interface. We call it physical function. And there is a port that faces host. Host thinks that it's an uplink, but basically it's DPU logic. PF. And certain virtual functions can be facing hosts. Another important concept, the so-called software model of physical ports in DPU, or representer ports. Since it has its own control plane, there should be a special interface that has to be used to manage everything, to make sure some rules can be uploaded regarding the packets and how you basically, so they're called the representer ports. And probably the most important part is the embedded switches. So embedded packet processor, it's a full switch that creates meta-action rules. What happens to that determines what happens to the packets that came through uplink and so on, and how you route them. And it's very flexible. There are a lot of tables, and you can see more details on this slide. I want to be describing all the details here, but I'll tell you that there are a lot of hardware tables that determine the rules for ports, like uplinks, host, and so on. And there is a key field, which is a match. And it can match based on all the any headers in the packet. And eventually, and so on. And on this basis, based on all that, we got this idea that this is enough to move the whole functionality to host. Moving this border from switch to adapter in each server. And in terms of functionality, it'll do the same thing. It'll be routing, it'll be overlaying, bridge, and so on. But in terms of management, it'll be managed like a top-of-rack switch. Be BGP or EVPN control plane and Linux networking stack and so on. So we have two main use cases, like cloud case, purely cloud case, where it's based on EVPN on switches, and you can move this overlay to DPU, creating creating the clones for all the hosts, having the end-to-end factory, basically disaggregating the network. So the application will be running independently of the server. Another case is accelerating routing on host scheme. When routing is happening on host, you can route on the DPU, and you won't be using CPU cores. So that's how it can be displayed. So you have DPU adapter. There is a control plane with EVPN or with the standard routing. Adapter creates BGP sessions to switches. And it's very transparent for the server. It doesn't matter what kind of applications or operation systems that run there. Basically, it's a model of a switch within the server that's in front of it. If we talk specifically about EVPN, it means that we move things here and we have everything on the host, on the adapter. And probably there are two models of implementation. One model is about checking all the services, including bridging and routing. It's all in DPU, and there is a single interface that supports XLAN trunk. And it doesn't matter what's run on the server. And everything that came from host can be VMs and so on. And you just set it up the regular way. And the second case is SR-IOV. When you have VMs and you want to speed them up, providing the same services, then on GPU you set up SR-IOV, and presents not a single interface facing the host, but several ones, each for every EVM, and then you set up every EVF and you map it against your DNS and services. Few more details on how it's implemented. If we talk about hardware, well, clearly DPU is a single chip that contains the data plane part, acceleration, and the processor. And this is standard Linux core with standard things like routing, bridging, and so on, anything that can be done on a regular server in Linux. Then in user space, we have a protocol stack, FRR. We have additional control planes like LLDPD and so on. Same to what you have on switches.
So, and moreover, there is standard Linux toolkit for the tuning and CLI. So all it's on the top right, this block, which is responsible for offload. It can be compared user space driver, which is network Linux, and loaded it's like hardware rules on data plane DPU switch. For this, we use DPDK software, which works and sniffs everything which Linux core learned, all routers, all MACs, and describes it with all standard interface in terms of rule of load or DPDP. case. So if in terms how it looks like in terms of users, in our case, we provide this service, which we call HPN. So as a separate container, which is installed on DPU. DPU, it's service with Linux. So it's very convenient deploy container. So it should be loaded on DPU. It will be deployed there. It starts to provide service VPN or service routing DPU. And in parallel in DPU, it's standard Linux tools in terms of IP route 2. And some orchestration optimization. So I've considered this solution in general together with switches. There are two approaches of automation. First, you take ready-made tools, Ansible, Playbook, whatever, which you already deploy, switch. And because DPU in terms of management doesn't distinguish from switch if it's Linux, and then you just extend those roles and deploy DPU. And DPU works the same ZTP like in switches. So in this case, DPU, it's not really different from the classical ones. And the second option, if it's server team, DPU has instruments and helps with provision like typical Linux server, and many use it former like a tool and or there are specific vendor tools which we deploy. So it's up to the user. And to sum it up, I would like to conclude to tell about our vision for network development. So host-based networking development, we consider it in the data center development. So if put this logic on the CPU device, so it can be so many advantages like protocols to connect. So usage of standard routing end-to-end in all fabrics, using SNP and balancing BGP and VPN for routing or for overlay services. So this simplification of networking for the host side, so it will be very transparent, and everything which is going on in this with this setting on hosting it impact on DPU, it can be managed by network team and end-to-end policy networks, so which is related to switches and servers. So in terms of operations, in this solution it's very easy to conduct maintenance because it's routing network, and you can extract switch through exploitation to redistribute routers on different switch. These classical solutions with ring aggregation is quite more reliable and simpler. So I think I'm done. I'm over. And if you have questions, I'm glad to answer. Thank you for presentation. I have two questions. First, scaling. Because as far as we know, in modern commutator, what type of scaling DPU has? So amount of flows can be written DPU. So now it can be calculated up to millions. So as far as our realization of DPU in chip itself, there is no special memory for this flow. We use operational memory on DPU. An amount of it quite big, 32 gigabytes. It's enough for blockbuster. And pipeline on TPU, because it's flow-based, then realization of classical routing, PM on CAP, on base flows. It's quite not trivial task, which demands several layers of pipeline, several tables of transaction between them, and matchings. So, and for routing utilization, it's increased. So, and of course, it depends on every case. At the moment, this solution, we have on-prem release status. We can demonstrate it already, and we expect release in the beginning of next year. So our target is that in the first release, we will guarantee scaling approximately up to 10,000 DPU in one pod. One pod, I mean unified DPE with the integrated topology, about 10,000. Okay. What constellations will be supported? It's a good question. So as far as for the smart network adapters and DPU, like superset of all smart networks adapters, then the capabilities of tunneling compared with switches, they're bigger, they're wide, and we support VXLAN, GNIC, GRE, VGRE, and Pelios URDP. We support also, and to realize any tunnel at the level of adapter, it's much easier than on switch. Here it's very wide field for thinking, for fantasies. My name is Fyodor. Thank you for your presentation. I have two questions. First, what is the real productivity of those adapters of DPU? Because besides data planner, control player takes resources. And the second question, given your practice, who is responsible for operation of these adapters? Server team? Thank you very much. Very good questions. As far as for the productivity. So flow-based forwarding on DPU realized due to it using its RAM, ordinary RAM, which is associated with ARM part, with CPU part of this adapter. Then theoretically there is no limit of scaling, but there is limit of the productivity growth. Because extension of memory it's not for free, and we use smart cache, and the productivity it's not linear. So if it's not big amount of rules, flows in DPU, you can get productivity about 80 million packages per second, and packages 64 bytes. As soon as you load it, million rules, you will get productivity several times less. But it's still better than soft on switch. So with million we have about 15-20 DPS we can have. And the second question about responsibility. So at the moment the solution we expect to release, and networkers, engineers, they want to separate from the team of software, and they want to be responsible for network and hosts, and for server engineers to leave one port when they don't need to tune bond rounds, nothing. So probably 80% of such discussions we have at the moment, and 20% there are discussions related to one team. An application team wants to accelerate network and speed up productivity and to use standard protocols. Good afternoon. My name is Yegor. I want your product. I want to give a comment. So, zone responsibilities of service networks. Why don't you grow a staff for operating adapters TPU? But it's not a question, it's just speculating. So and the question is, before it was video cards with the radiators, then video cards, grown, filters, liquid cooling, etc. So you understand that you have created a product which consumes resources. Your RAM will experience heatings also. Yes, it heats, but not that much like you consider this. So there is no active cooling on those adapters. On DPU, we use passive radiators like on ordinary cards. They're just a little bit bigger, and we try to be in limits of power according to specification of PCI. So different variations DPU, there are different models, different speeds. They could be powered from PCI slots. Can temperature be impact on productivity? Yes, it can. Yes, that's why we have very detailed guides, and we're testing it very carefully in terms of temperatures, the range of temperatures, in order to make DPU to perform maximum. On the other hand, because it's ARM processor, it has a regime of automatic control and productivity control on ARM. But as I said, the most magics of performance is made on installed blocks, which doesn't consume cores. So productivity of those network blocks doesn't relate to temperature. And the last question. Cisco company Andrey Vishnyakov, very interesting report, very interesting approach. Every rack has two tops, the rack commutator. What's the problem? Why two? Because we enter into the process of upgrade of sorts on this top of the rack commutators. When you suggest to implement those tools in servers, I have a question. Your minimum implementation should be to those cards. If one card, okay, so how you consider to make in-service software upgrades? And another question, maybe 2 times more to increase points of configuration of network management. So it's significant complication of the current architecture of node. Like probably you suggest you offer some kind of automation of the system switch on the server adapter. I start from the second question. As far as for the automation and points of control, yes, it's getting more of them. We don't plan to unite all of them in one control. We just follow away on distributed control plane when they are autonomous devices, but due to automation, you can control them in big scale. There are ready-made products which can make mass deployment and manage cycle of deployment. We have ready reference playbook on it, and its extended capabilities in terms of automation of switches. There is no one united system which could be responsible for all aspects of DPU. Here, probably it's more open platform which can be used vendor systems or switches systems. So here we don't see problem which. And the first questions as far as for the upgrade. It's been solved now. We have opportunity now, capabilities to solve it, to update the same operational system, Linux with the same services which works on DPU without service stops, hitless. It's been realized due that we have additional logic which can be autonomous. As far as for the fault resistance, yes, you're correct. If there are two network cards and could be reserved between them, but here CPU 1, and if it fault, then it will be collapse of server connections for the cloud data center and customer. This is not a problem according to our practice. They use even one commutator. For an enterprise, it could be a problem. So for them, we think in the future in enterprise it comes, and it needs time for scaling. First, it's practicing in cloud, and then it comes to enterprise. Thank you. So, and let's come to the end of our conference. Thank you very much that you all stayed with us. I hope it was very helpful. The most important, please fill in feedback form. Why do you need to do this? Because you can win merch from us. Super hoodie. Guys, super hoodie. So one more time, I remind you, after conference, we have a party in Frankfurt. It's close. You can find it in Yandex. And now, so let's congratulate our winners. Winners of questions. So, sorry if I pronounce surname incorrectly. Yegor Gomzin. Yegor, come here. We will give you T-shirt or merch. So there is a prize for you, a gift for you. Leonid Ryzhnik, please come here. Evgeny Zubnitsev, Evgeny, please come to the stage. Vladimir Kononov, please. Ilya Somov. Alexander Fatin. So your question impressed Andrey Nushtaev. Vladimir Kupriyanov, Alexander Pavlov, I think, as I understood, they are from online. So we send them by post. Vladimir and Alexander, please write to me and we connect to you. Thank you for your interesting questions. Thank you very much. Thank you, everyone, speakers, viewers. And wait. It's not all speakers, all program committee, come here. So let's look again at you, upload you, make photo, and then we finish our conference. Okay.
Спасибо большое, спасибо тем.
Thank you very much. Thanks for staying for 12 hours of presentations. And with that, we finish NextHop 2021 and see you next year. And now it's party.